posters, where around 110 and more than even posters have been selected for participation throughout these 2 days of conference. Department of Pharmaceutical Technology, which is one of the biggest departments of JIS University, which runs the courses like B Pharma, D Pharm, BMLT, that is Bachelor in Medical Laboratory Technology, M-Pharm in 4 different disciplines: pharmacology, pharmaceutics, quality assurance, pharmaceutical chemistry, and also runs PhD program for the doctoral degree. Who's organizing an offline conference for the first time, which requires your cooperation, your support to achieve a great success. So by manifesting the success of this scientific event and with this positive note, I would like to call the dignitaries, our respected dignitaries in the dais. Firstly, I would like to call our respected Honorable Vice Chancellor, Professor Bhavesh Bhattacharya, sir. I would like to call Professor Bishwajit Mukherjee, sir, ex-professor and HOD, Department of Pharmaceutical Technology, Jadavpur University. Professor Tapan Kumar Chatterjee, Dean Pharmacy, JIS University. Professor G.L. Latta, BOS member of JIS Group. Sir, please come on the dais. Professor Pintu Kumate, Principal, JIS Institute of Kolkata. And our very own, our departmental HOD and Dean of Academics, Professor Himanshu Shekhar Maji, sir. We have our dignitaries in the dais. Now, I would like to call our professor, Professor Kamalakanta Roy, sir, to felicitate our Vice Chancellor, sir, Professor Bhavesh Bhattacharya. So, volunteers, please coordinate. Give a big round of applause, everyone. Thank you, sir. I would like to request KKR sir to stay back, and I would like to ask and request KKR sir to felicitate Professor Bishwajit Mukherjee sir, ex-HOD professor, Jadavpur University, Department of Pharmacy. Thank you, sir. Thank you. I would like to request our HOD, respected Professor Himanshu Shekhar Maji, to felicitate our Dean Pharmacy, Tapan Kumar Chatterjee, sir. I request Maji sir to stay back and felicitate Professor G.L. Latta, sir, POS member of JIS Group. Please give a big round of applause. Thank you, sir. Thank you. Thank you, Maji, sir. I would like to request come upon on the stage Dr. Topon Kumar Shaw, sir, to felicitate Maji, sir. Sir, please. Give a big round of applause, everyone. Thank you, sir. Thank you so much. Thank you, sir. Now, I would like to call on the stage the convener of this conference, Dr. Payal Chakraborty, to felicitate Professor Pintu Kumar De, Principal, JIS Institute of Poland. Give a big round of applause, everyone. It's a moment of recreation. Thank you, ma'am. Thank you, sir. Thank you all the dignitaries in the dais. As we know that as the first ray of sun brings a new hope to start the day, similarly, lighting the lamp in such auspicious occasion will illuminate the abundance, knowledge, and success to this station. With this positive note, we would move forward to the next session, next program of our session, that is lamp lighting and the inaugural song. For that, I would like to ask the volunteers to help here. Volunteers are requested to come here. Volunteers are requested to come. Thank you so much, sir. Thank you. Please take your seat. For an enlightening and encouraging and obviously refreshing inaugural song, we have our students in the stage, Joybrata Guhoroy, Noran Bhattacharya, and Shreya Chaudhary from the Department of Pharmaceutical Technology, JIS University. Hello. Hello.
विधात्री वरदे नमः गुरुपंदे जयंते यशोदेहि यशोदे महिषासुरनिर्नाशि भक्तानां सुखदे नमः
गुरुपंदे जयंते
यशोदेहि यशोदे
धूम्रनेत्रवदे देवी धर्म कामार्थदायी रूपं देहि जयं देहि यशो देहि दिशो जयि रक्तबीजवदे देवी चण्डमुण्ड विनाशि रूपं देहि जयं देहि यशो देहि दिशो जयि
शुभनिर्नाशि त्रैलोक्यशुभदे नमः गुरुपं देहि जयं देहि यशो देहि दिशो जयि वन्दितां ह्रीयुगे देवी सर्वसौभाग्यदायिनी गुरुपं देहि जयं देहि यशो देहि दिशो जयि
अचिंत रूपचारिते सर्वशत्रु विनाशिनी रूपं देहि जयं देहि यशो देहि दिशो जयि प्रत्येव सर्वदा भक्ता चापरने दुरितापहे रूपं देहि जयं देहि यशो देहि दिशो जयि
भक्ति पूर्णं चंडिके वेदनाशिनी
रूपं देहि जयं देहि यशो देहि दिशो जयि चंडिके सततं युद्धे जयन्ती पापनाशिनी रूपं देहि जयं देहि यशो देहि दिशो जयि
रूपं देहि जयं देहि यशो देहि महिषासुरनिर्नाशि जयं देहि
Thank you, everyone. Thank you so much. Thanks for this encouraging and refreshing song, inaugural song. Now we are about to start our conference, the first conference of Department of Pharmaceutical Technology, JS University, Pharmanesia 2K23. For this, I would like to request our very own and honorable Professor Bhavesh Bhattacharya sir, Vice Chancellor of JS University, to give an opening speech and welcoming speech for this conference. So,
Good morning, sir. Good morning, sir.
Good morning, sir.
Very good morning to you all.
Good morning, sir.
Respected dignitaries on the dais, honored guests of this conference, my dear colleagues and dear students. At the very outset, let me take this pleasure to welcome you all to this first national conference of the Department of Pharmacy. This subject chosen for this conference by the department is extremely pertinent. Things which are very relevant to the society, present society, they are being taken up by the department. At the beginning, let me congratulate the department for initiating such an exercise. Friends, for the last century, we have advanced a lot as a society. We have developed ourselves scientifically, industrially. The civilization has progressed a lot, but it has been through a cost. Cost is something which we are perceiving nowadays through a hostile environment. Things we did not see during our early days are visible nowadays. Extreme environmental conditions are prevailing with more intensity and more regularity. Cyclones are very much day-to-day affairs nowadays. Both our East Coast and West Coast are affected because of that. Lot of disturbances are taking place. We hear about cloud burst now and then. We see dozens of people dying because of sudden lightning strike. There are floods, earthquakes, whose intensity and regularity has increased a lot. But this catastrophes, these things which are happening, something is not in the domain of today's deliberation, but some other thing which is happening, that too also in a more intense manner and more regular manner, the strike of various virus-borne diseases. It is becoming very regular nowadays. The multiplicity of those variants are very disturbing. We have tamed some of the known viruses over a period of the last century: cholera, typhoid, then AIDS virus. To some extent, during the recent times, Ebola, Nipah, and during the recent times, we have also tamed coronavirus. But the problem comes when something unknown comes into our frontier. We get really disturbed. We do not find solutions. And if we are trying to get solutions, the time taken to provide the solution and the initiation of the endemic or pandemic situation, it takes away a lot of lives from our civilization. I am not an expert in this field. I am almost a novice, but as a beneficiary, let us try to evolve something which forms a uniform domain of solution so that such viruses can be predicted and taken care of in advance. This will be a great achievement of this civilization in future. Friends, even otherwise also, when such situation arises, we find a divided society, have and have not. Majority of our population, especially in a country like India, is not having access to a reasonable quality of medical facility. It gives a tremendous toll in their own self and also family. The cost of medicines, the cost of other treatments, they are exorbitant for majority of our population. So I urge this community to create a platform whereby we can at least significantly bring down the cost of treatment, try to evolve things which are domestically available so that majority population is taken care of. I'm sure there is a great galaxy of eminent speakers during the 2 days deliberation. I'm hopeful that some of the good things which can evolve in future will come out of this 2-day conference. Friends, one more thing I would like to mention here. It gives a lot of pride to achieve something which saves the society. Recognition aside, the pride is significant. I will narrate one incident. Before ending, I will narrate one incident. This is during the Corona time. I was watching one of the matches of Wimbledon tournament. Suddenly, in the midst of the tournament, there was an announcement saying that one of the scientists from AstraZeneca, who had developed the vaccine, is one of the spectators of today. When this announcement was made, the whole of the stadium, along with the players, everything halted. Everything came to stand still. And the dead lady had to stand up to acknowledge the adulation given to her. So what I was trying to tell, achieving something in a frontier where it saves society, it saves general, not very privileged mankind, it gives a lot of pride and recognition. So I'm hopeful today's and tomorrow's deliberation will bring out some such great people among us so that we can declare their names with pride. I must congratulate the organizers and also the department for their initiative and wish the two-day conference all the success.
Thank you so much, sir. Thank you so much for your wish, for your encouragement to make this event successful. We just have our respected two dignitaries amongst us in the dais. I would like to request Professor H.S. Maji to felicitate one of our dignitaries, Professor Abhijit Sengupta, Director of Guru Nanak Institute of Pharmaceutical Science and Technology. So please. Please welcome him with a big round of applause, everyone. Thank you, sir. Thank you so much. I'll request Maji sir to stay back for a while. I'll request Maji sir to felicitate one of our respected dignitaries, Professor Neeraj Saxena, the Pro-Chancellor of JS University. So. Thank you, sir. Thank you so much. Thank you, sir. Now I request Professor Abhijit Sengupta, sir, to give a very warm speech for this conference. Sir, please.
Good morning, everyone.
Good morning, sir.
Very good morning. So it's once again in JS University. Every day I used to come, and nowadays, because I'm getting a little bit old, that's why maybe I'm not coming regularly. But my heart is always here, at least with the pharmacy department of JS. Honorable Pro-Chancellor, Honorable Vice-Chancellor, and most honorable our Professor G.L. Dattu. I know every one of you should know that Professor G.L. Dattu, such a dignitary, is present in front of us. And a person like Professor Saxena is present in front of us. That is the biggest honor to JS University, one of the biggest honors to the JS University. That's such a dignitary. Honorable Vishwajit Mukherjee, we are from the same university, we studied in the same university, and he has done fantastic in this profession. He has worked for this profession and he has come up like anything in this profession. Really, kudos to him. Pawan Chatterjee, Professor Maji, Professor Pintu Kumar De, we are all together. We have been working together in this pharmacy profession, and we have whatever we have achieved. Maybe it's very little, but at least before our departure from this life, we would like to make a mark, at least in this country, so that on the matter of pharmaceutical developments, and that I'm sure Professor Vishwajit Mukherjee, Pawan Chatterjee, Imam Maji, and Bintu Kumar, they will be definitely doing it. This kind of conference really brings a lot of hope and a lot of happiness towards the in the students of JSU. I hope it is mostly pharmacy students.
Yes.
But there should have been engineering and other students also, because pharmaceutical drug development or whatever, drug designing, whatever it is, now it is absolutely corroborated with technology. Engineering is a must here. Recently, we were in a meeting with Professor G.L. Dotto, and he was talking about this 3D printing. And really, 3D printing is coming up in a very big way in designing. It has already come in the field of food technology and also in the field of pharmaceutical technology. Especially, CAD is very much used. Every now and then, people are working in CAD, that is computer-aided drug designing, and particularly 3D printing. With 3D printing, a lot of things, experiments are going on for printing this capsules and all, tablets, etc. There are so many designs which are coming up with 3D printing. So, with my limited knowledge, I will not like to go into the different fields, and especially today's conference topic, that is about the chronic diseases, because India and the whole world is facing a lot of diseases, particularly the viral diseases, and India is still now, and in this 2023, we are still facing problems with tuberculosis. This menace and resistant tuberculosis, this menace is not going away from India. But I hope and I wish that people start working on that with new endeavors, new visions, new perspective, so that we can eradicate these kind of things. We have already nearly eradicated polio, but tuberculosis is also a thing. Things like malaria, things like dengue, we are still fighting with it. There are a lot of technologies required to go against these diseases. I think the future students will take an endeavor to work on these diseases. Thank you very much. Wish you a great success. Thank you.
Thank you so much, sir. Now I request Professor G.L. Datta, advisor and POS member of JIS Group, to enlighten this program with a speech. Come.
Good morning.
Good morning, sir.
One feels indeed very great to be here in the midst of such enlightened galaxy of experts, would-be experts. We have in the dais persons of great eminence. They are shining stars. Great scientists only will know their names. I am not one of them. And hence I don't know their names. But all that I know, they are shining, great experts in their own fields, domains. Friends, I feel deeply honored, deeply humble person. I have been a very simple teacher, very ordinary researcher, and a very ordinary administrator all my life. And that's about more than 5 decades have been in this profession. I would like to, at the outset, congratulate the organizers for thinking of organizing an event, a national seminar with such a great theme, so much pertinent today. I would like to congratulate all of you, in particular my very dear student, the future of the nation, future of the globe, to be here. Science and technology have been advancing at a great pace. And it has been damaging the environment at a greater pace. And the nature has been taking up this challenge by means of different kinds of diseases and things like that that you find today. And pharmacies, per se, with all the verticals that you have, specialization that you have, you are to take the challenge. And you are taking up the challenge, which is making us very proud today. To my mind, if the civilization has to sustain, it will sustain through with the help of, because of the development's contributions in the area of pharmacy. We talk of food, what Sengupta was referring to. I have some interest in that. You talk of any kind of virus or things like that, which appear, disappear, reappear in different forms at different times. You are to take up the challenge and thus sustain the civilization. Yours great profession, I must say. I feel proud when I get such opportunities because of my some association now. I feel very proud to be in the midst of that. Great. This conference, I have no knowledge, negative knowledge, expertise. But I am very sure the great experts who would have assembled, who would be delivering their lectures, would be very enlightening for all of you. To the young student friends, I would like to urge on you, this is a great opportunity for you to move ahead in the field of your profession. Don't ever believe it. Take it up very serious. It will give you an opportunity not only to know what is happening, what is going to happen in future, but also will give you an opportunity to network. Networking is very important for you to be able to contribute your life. And all of you will be able to. This is another thing which I strongly believe. All students are talented. The difficulty is we are looking for talent in a particular discipline. And hence, some who do not fit into that discipline, we say they are not talented. Very wrong. And you must look for your own talent and shine. You would be able to. Best of luck to all of you. Thank you very much.
Thank you so much, sir. Thank you very much. Thank you, sir. Now I'll request Professor Vishwajit Mukherjee, sir, to add values to this conference by his work. So, please.
Very good morning, respected Vice Chancellor, sir, Pro-Vice Chancellor, Director, NIPST, Professor Dr. who just left also, Dean, Professor Tapan Kumar Chatterjee, Professor Pintu Kumar De, then Dr. Himanshu Maji, head of the department of this pharmaceutical sciences department, my dear honored speakers, distinguished guests of the class, my dear students, ladies and gentlemen. Today, first of all, I'd like to convey my sincere gratitude and thanks to this organizer to invite me to share some of my views to you. And more particularly, I want to convey my sincere gratitude to Dr. Payal because she actually was instrumental to bring me here. So thank you, Dr. Payal. I understand that this is the first conference you are performing here, Pharma Asia 2K23, and topic is very interesting. Advanced therapeutics for life-threatening and chronic diseases. So there are several diseases we understand to be chronic diseases. Like more commonly, if I ask you, you will say diabetes, you will say cancer, you will say even like little early Dr. Sengupta said, it is the tuberculosis, even the leprosy, but major other threats are equally there. Example is, this neurological diseases. There, sometimes we don't believe that they're life-threatening, but they're equally life-threatening. So, you see, many cases, hypertension, that is also a chronic disease. Cardiovascular disease, that is also a chronic disease. So chronic disease, it is very difficult to treat. I just simply give you a brief understanding of these diseases and our way, how we are approaching it. Because this particular conference, we are going to discuss that is on the advanced therapeutics related to these diseases. Now, if we just go back to the 19th century, what we had, normally the development of the basic sciences, physics, chemistry, biology, and the great personalities also performed very well, like Thomas Alva Edison has contributed a lot. Edward Jenner, beginning of the idea of the vaccination. So it is there. 19th century, after that 20th century. 20th century, what did you get? Many, many important things. First, therapeutic chemical, what we call the modern drug. It came in 1907 by some German scientist. I think his name was Bartheimer, something like that, I forgot. So, important issue is that is the beginning of the modern era of medicine. You know that you have got the penicillin discovery that actually saved the people. And Alexander Fleming, after the discovery on one occasion, he said that thank you to penicillin, now you can have gonorrhea twice a day. It was a sexual transmitted disease, and gonorrhea, there was no treatment. So, see the discovery of this antibiotic care. Forget about that. What are the major invention? X-ray is also there. This is all related to the genetic code is also there, which gives the inception of the molecular biology, which gives the idea to understand the disease at the molecular level. Very important. If you want to work with the drug and therapeutics, it is very important to understand how the drugs are working. It is not so simple. I will discuss maybe a little bit about that later on. But other than that, other major technologies like flying technologies, which improve a lot, like that brings a new idea, new things to the people to develop. That is, the aeroplane, satellite, sending satellites, whatnot. Then television, and then computer. Why I am telling you, among them, you see, like biological cases, molecular development of molecular biology was one of the greatest achievement. Development of the drugs, including the antibiotic, was the greatest achievement. also the flying technology aeroplane, and the major achievement of this last century was the computer, which brought a new avenue voluntarily. Now the focus is what is the contribution of the present century? What is it going to give to us? You know what? AI, artificial intelligence. It can do a havoc in every case, including medicine, including many other aspects. We are mostly concerned about the medicine. So we will discuss about that only in a very nutshell, that what you understand that presently, if a person can be operated using AI, there's no need of doctors. You know, now it is possible. Earlier, you know, if you have some clot in the brain, you have to open the skull and operate it. Many cases it was unsuccessful. Nowadays, the strain you are giving to, you know, for removal of the block at the heart, same thing is going to be used in brain, and it is successful. It has been already, you know, successful in the level of therapeutics. Most important thing is there is a severe problem regarding this neurological damages. Neuron, it doesn't, you know, replicate. It is the nerve cell which cannot replicate. You know the reason behind it. They don't have any central nerve, so they cannot replicate. Your nerve cell with damages, it damages forever. So in those cases, you see, like that's why people are having paralysis, people are having some neurological diseases like arthritis, gout, many other cases, you know, people suffer a lot. Now they're developing some microchips using the same technology, you know, this string that is going to be brain, and from there it is regulating the part which are damaging. So that's this like a bypass system and giving you the same sensation, and the arthritic patient, paralytic patient will sooner or rather get lots of, you know, changes in their lives. Imagine the blind people could not see. Now, as you understand, Israel developed one spectacle by which blind people cannot see. So imagine it at which level we are going to face the future days. Science is not limited to the laboratories. Science is limited to your brain. We don't have anything. We don't have nails to sketch. You see, tigers or even the cats, they can take your muscles from your body by their nails. We don't have the teeth to bite in such a way we can damage somebody. We cannot run even to compete with the cats and rats. They will run faster. Then what we have? We have this brain, nothing else. We don't have anything which is comparable to even an ant. His biting will be painful, you know, but your biting will not be painful because you don't have any poison. So important issue is that in spite of all this failure in the human system, we have a very important thing which is uncomparable to any other species, that is our brain. So research is limited not in the laboratory. Many people think, I don't have this, I don't have this, how can I do research? Must you do your research using your brain. The future generation, I understand here number of people are there. I know many of them are very, you know, potential, like Dr. Palit is there, Dr. Sati is there, Dr. Mukhopadhyay, Bandyopadhyay is there from NIPAR, many others. But I understand their potential. They have lots of things to disclose to you in coming few hours and as well as maybe tomorrow. That will help you to enrich. See, important issue is that gathering in a seminar just to get a certificate or for food or any other thing is not at all important. What is important is that absorb the essence of science, absorb the essence of the speaker who are speaking, what they're going to suggest you, what they're going to share with you, try to think of, try to develop from that. And if your effort is there, if you are very sincere about your attitude to do better science, you can do it. Science, I repeat once more, that it is not related or it is not limited to laboratory. It is mostly you have to use your brain, because science means if you want to involve in science, you have to think from the when you are just getting up till you go to bed. Your brain cannot enjoy the recess. So this is science. You have the love for it, you have the affection for it. It is not that getting a PhD degree is science. Degree never can be equated with the education. Degree is just you can achieve by cheating, by copying, by several other means. Education, you have to imbibe, you have to assimilate. Nobody is there in the world who can educate you if you don't want. So this is a very important message I'm just sharing with you. Try to understand, give the value of this, that try to educate yourself. Do not just involve to get the degree on. Get the degree, obviously it is required, but simultaneously, you have to educate yourself. I just wish this particular program grand success. I also understand this, my fellow learned speakers will help you to enrich. And when first day end or the second day, you will leave from this room, you will say, yes, whatever knowledge with us, that has been increased, at least incrementally. That will be the success of the program. If it is not there, this program has no sense. I believe that you should achieve it because I understand many of the speakers are known to me. Thank you very much. I wish the best of this particular seminar. Thank you.
Thank you so much, sir. Thank you for reminding us that the research is not limited to the laboratories, which we often used to think, which is limited to our brain, which we often do not use to utilize the research, to do the research in the depth. And thank you for reminding us that research is not only about getting a degree in terms of PhD and others, it is about utilizing our brain and do something innovative with it. Thank you so much, sir, again. Now I would like to call on stage, I would like to request Professor Neeraj Saxena, the Pro-Chancellor, to say a few words about our conference. So, please.
Champions, promoters, and enthusiasts of pharmaceutical sciences. My greetings to all the learned members present here. This occasion of conference, national conference that is being organized for the first time. And I must congratulate the team which has taken the step for the first time, and as I'm told that they are going to host an international conference also. I'm a ranked outsider when it comes to pharmacy. I have no idea, but I did have some brush with eminent expert from the community when I set up few centers in pharmaceutical sciences. The first one was in JSS College of Pharmacy in Uti, that was in Herbal Drugs, and the year was 2000. We set up another center in New Drug Delivery Systems. I had no idea what it was in MS University, Baroda. MCOPS, Manipal College of Pharmacy, that was in pharmacogenomics. So these are the terms I am familiar with. Other than that, I have no idea. But I did get chance to interact with the faculty in this group, also the university, when we are trying to draw a proposal to submit for SARTI, and I spent about 20 days sitting with the faculty over here and trying to understand knowledge and their experience. One of the points which was stressed upon by the previous speaker, Mukherjee, about the AI. I think that is the tool of future. If it was calculator, then computers in the previous century that was pushing the frontiers of knowledge, is now the time for AI. And I personally feel that whatever human intelligence could find through the investigations has almost been found. And what is not known is much more be known. And for that we need AI, and we will need the involvement of computer scientists in this domain. So I would like to see that in the next conference, international conference that we are planning, we should have some participants or some experts from that domain also. We are in the age of artificial intelligence and advanced computational sciences. And we have come to a stage when we should start thinking of using or outsourcing our memory functions to the computers, to the machines, and leave thinking for ourselves. As Dr. Mukherjee was also insisting, thinking is very important, and that's what sets us apart from the rest of the species. I'll stop here and look for outstanding deliberations and very good insights for the researchers here, so that we get very good quality research conducted in our campuses and also in our university. Thank you very much.
Thank you, sir. Now I would like to call Professor Tom Kumar Chatterjee, sir, Dean Pharmacy, JS University, to encourage us with his warm words. Sir, please.
Respected Vice Chancellor, Professor Maji Bhattacharya, Co-Chancellor, Professor Neeraj Saxena, Professor Vishwajit Mukherjee of Jadavpur University. He is an eminent pharmaceutical scientist in this field. Professor H.S. Maji, who is the head of the department of pharmacy department, and Professor Pintu Kumar Dev, principal of Kollani Pharmacy departments. And the other distinguished persons of the dais, my colleagues, organizing committee members, and my dearest students, very good morning. It is my great pleasure to invite you all to the national conference known as Tissue Farmaceutics 2K23 in the physical mode on the theme that is advanced therapeutics for life-threatening and chronic disease. Before going to the point, I will give you the other way, the inventions related to the diseases that are very life-threatening indeed. On 13th of April 2024, 8 scientists have been declared the recipients of the breakthrough research that is equivalent to the amount of each person will get the $3 million, and that will be in the Los Angeles the next years. What they did actually, what they did. First of all, you have to know the names of the scientists. That is Thomas Gassers, Andrew Singletons, and Alan Sandescos, who did their unique job in the field of Parkinson disorders. I'll come to the point next, what they did. Along with them, Carl Jones and Swan Gettings are getting the CAR T cells developments related with the cancers. And Michel Sadens and others also get that breakthrough award for their breakthrough research. So one by one, I'm telling you their research and why they are chosen for their research. What they did, actually, you know that cancer is a deadly disease, obviously. All of you know. Cystic fibrosis, another disorder that is also dangerous for the person suffering from cystic disorders, cystic fibrosis. And the other thing is that deficiency of dopamines in the brains, that is also a genetically oriented disorders, which causes dyskinesias and tremors, and ultimately patient may die. So these are the factors, and they address that factors in such a way that the scientists who developed the treatment of a cancer, that was CAR T. What is CAR T? CAR T is chimeric antigen receptors T cells. What is chimeric? Chimeric is a word coined from the literatures that it is a monster that has two heads, one of the goat and another of the lion, with serpentine tail. They are only the living drug that can catch the antigen of the cancer cells, and that will be inhibited like that. So the treatment protocol is like that. Whole body drug is drawn out from the persons. It's a continuous process who is suffering from the blood cancers, and then the T cell is separated from theirs. They are engineered in the laboratories within 2 to 3 weeks. Then again, that T cell is injected to the same part for the treatment. What they do? Normal cell, normal killer cell, cancer killer cells are not knowing the exact points of antigens of the cancers. But these cells, this CAR cell, can identify the antigen part of the cancer, and ultimately that will be inhibited. And cost is used for treating only one person, because this is a very much personalized drugs, and cost is around $4.5 lakhs only for treating a person. That was their research. For that, the person are involved with this research is getting the breakthrough awards on 2024 in the Los Angeles the next year's, means for their research CAR T. Now the coming of your cystic fibrosis. It is also a very dangerous disease. It is the imbalance between the salt and water. Very simple. Salt and water imbalance causing the thickenings of the mucus And that thickening of the mucus is causing the clogging of the different part of our body, mainly is the respiratory systems, where our respiratory systems is involved with the capillaries of the tubes, where they are deposited and causing the free air flow for that. Or in a gastric region, where they are also deposited, and this part is a part which are attracting the bacteria, virus, etc. So they have found the exact mechanisms behind that. What is the cause of these diseases? That is known as cystic fibrosis condition, that is cystic fibrosis, transmembrane conductions genes, the variations of that genes or the genetic changes of that is causing these. They have engineered that, and again the normal conditions will get back. So this is also a breakthrough research to treat the person suffering from this cystic fibrosis. Very dangerous disease, and the thing are coming in the near futures, the cystic fibrosis will be controlled. The another ways, that is the person who are suffering from the deficiency of dopamine, and that is derived from stored substantia nigra of the brain, that is the black part of the brain. And deficiency of these dopamine is causing these kinesias, means the movements will be very much disturbed along with the tremors and others. Ultimately, patient may die in the futures. So the person who was involved with this, he was doing a research on the brain cell of the human beings. He was doing what is the factors causing these disorders. He ultimately found, this scientist, that glycoside-related delta 1s, that is the GBS 1s, is causing the Parkinson disease. He engineered that, engineered in such a way that Parkinson disease, even the Parkinson disease can be controlled in their futures. These are the advanced research we can get in futures, because these 8 scientists all over the world was chosen for getting this breakthrough award. And this award is known as the Oscar Award of World. Each person will get, again I am reading, that they will get $3 million each for their novelties in the research and breakthrough research on all that things. And all of you know the other disorders are happening, and pharmacists are doing the best in the laboratories, drug monitorings, drug deliverings, different ways that we are constantly fighting against the diseases we are facing. And with that, we are taking the technologies from this type of technologies, means engineering or other lecture was coming with the AI technologies, and another research is now going on in the Harvard universities. What they did, when they were finding the same type of cancers is happening in the 2 persons, the same drug was applied, but one person is responding very well, another one was not. What was the cause? They find that some thing is happening in the cancer cells, so they develop in their laboratories the 3D structures of that cancer cell in their laboratories. They find out the exact drug for that killing of that cells in the 3D models, and find out the exact drugs for the exact persons. So it is very much personalized. Drugs will come in futures to control your disease conditions of the cancers like that. And that was published in the paper Nature, and giving a very great encouragements to the rest of the world who are suffering from the cancers and others. And I will not talk too much of that because many persons are there for listening. The good speakers are waiting. So these are the views I have just mentioned, that how the science is going on beyond of that normal drug synthesis and others. In the other way, you have to attack the disease condition so that you will get the good results in futures, and our life will obviously be better than this day, and tomorrow will be better for us. And this conference, obviously from this conference, we get more and more this type of informations and others, exchange of the informations through them. And the students who are listening all these things or go inside of that, obviously you will be in futures, will be a great inventors to invent some drugs for betterment of mankind. Thank you very much.
Thank you, sir. Thank you so much for shifting the focus on to the theme of our conference, that is advanced therapeutics for life-threatening and chronic disease, by focusing on the disease like cystic fibrosis. Thank you so much, sir, for that. Now I would like to request to come on the stage and give a warm speech to this conference, our very much own ex-professor of our department, and presently he is the principal of JIT Institute of Pharmacy, Professor Pintu Kumarte. So please.
Dr. Maji Hello. Very good morning. Respected Pro-Chancellor, Dr. Neeraj Saxena, Vice Chancellor, sir, our beloved Dean Pharmacy, our own HOD, Dr. Maji, my mentor, Dr. Vishwajit Mukherjee, and my previous colleagues are there sitting in the chair in front of me, Dr. Sati, Dr. Partopali, and another speaker, Dr. Sandeep Mukhopadhyay. So all are gathered here to share their knowledge in this occasion. I am also feeling privileged and honored to be invited here and to be the part of this first national conference organized by the Department of Pharmaceutical Technology, that is Pharmanesia 2K23. And the theme, if you see the theme of this conference, very, very important, very delicate topic, which I think mainly reasoned by the clinical aspect, it has been chosen, and very pertinent, very interesting topic. So many things which will be discussed, which is going to be discussed. I think it has not been covered in your syllabus or curriculum. So we will also be enriched while the speakers will speak about something. I'm just giving you the meaning of this topic, what I understand. The topic is advanced therapeutics for life-threatening and chronic disease. Now, by this time, you have idea about some of the chronic disease, which are very problematic. Sir has told already, like diabetes, cancer, so many common diseases are there, tuberculosis, leprosy. But these are not nowadays disease. These are prevalent from our childhood. We learned about this, and very good medicine was there. Even if you think about malaria and dengue, what is going on by today, that is life-threatening disease. It is not nowadays. It was prevalent from our childhood, disease of 19th century.
or before that date. And that time, you never seen, I think nobody can remember that that person died for malaria. That person or that his relative or her relative died of malaria. We have heard people are suffering from malaria and the typical symptoms of malaria. You can understand he's suffering from malaria. আমরা বলতাম ভালুক জ্বর হয়েছে ভালুক জ্বর মানে সিভিয়ার কনভালশন হতো জ্বরটা এলে then by simple treatment simple therapy we can recover but nowadays at this present days you can see number of patients are dying of malaria and typhoid and tuberculosis and in dengue it's a deadly disease. Why this thing happened? Is there no medicine? Yes, obviously there was medicine, very good medicine. Sarah mentioned about penicillin. Swisser mentioned about penicillin. It was a great medicine, and there was no disease which can be cured by penicillin. Regarding syphilis, gonorrhea, not only that, meningitis. The single dose or 2 dose may be sufficient. Nowadays, it is not working. That's why this is very pertinent to discuss about the modern therapeutics. What is modern therapeutics? What is the borderline? What is the difference between the modern therapeutics and the conventional? Whenever there is a modern, there must have some conventional therapeutics. So you should understand the borderline. What makes the difference between these conventional therapeutics and the modern therapeutics? Conventional therapeutics, whenever we are talking about the therapy, we are thinking about the drugs. And if I ask, everybody will say something about drugs. Can say something about the drug. It's just a chemical which gives you the physiological changes or give the pathological benefits. But what is modern therapeutics? There is the, as Sarah is told about the 3D printing, personalized medicines. This is the regenerative medicine. Regenerative therapy means which comes from your regeneration. We are thinking now for the regeneration or repairing or regeneration of the tissue, cell or the organ. So whenever we talk about the gene therapy, the somatic cell therapy, tissue engineering, monoclonal antibodies, all these are not very old. These are the coming days drugs. When the conventional drugs cannot work, now the scope of research, scope of discussion is very, very large. So that's why we have assembled here, so that we can discuss about this modern therapeutics. This is a separate category of drug. This is not the general chemical or protein, which give you the disease, curing the disease, which are we are talking about the disease which are not cured by the conventional drugs. So we are now thinking for the advanced therapeutics, which is mainly concerned with the regenerative medicine, which can repair or regenerate your cell or tissue or the organ. So we are regenerating it and we are doing it by tissue engineering. That's why Sarah telling you that they have given the suggestion that so that we can include the biotechnological department, the AI, all the departmental students can sit together and discuss to get the solution, to find out the solution of the diseases which cannot be cured by the conventional therapy. Thank you.
Thank you, sir. Thank you so much. It was a pleasure to hear from you again after a break. Now I would like to call for a warm welcome speech by the departmental HOD and Dean of Academics, Professor H.S. Maji. Sir, please.
I'll make sure that your time is not wasted. So we are already running behind the time schedule, and I'll not take much of your time. And the customary to say something. And I limited to that part only. Honorable Pro Chancellor, sir, Dr. Nidal Saxena, Honorable Vice Chancellor, Professor Bobis Bhattacharya, my teacher, Vishwajit Mukherjee, sir, from Jadavpur University, Dr. Pintu Kumar De, our colleague, ex-colleague, and current colleague, also Principal of JIS Institute of Pharmacy, our beloved Dean, Sir, Professor Tapun Kumar Chatterjee, and in the dais we had Professor G.L. Datto, the advisor of JIS Group, and Professor Obhijit Sengupta, the director of GNI PST. Many of you, many of our students doesn't know that our department has started with the hands of Professor Sengupta. So he has got a golden touch to start our department at JIS University in 2016. Of the dais, I can see Sadhidi. She is doing fantastic globally. She is doing good research on cancer biology. And I strongly believe that she will impart lots of knowledge into these 2 days conferences. We have Dr. Sundip Mukhopadhyay, eminent scientist. I can also see that Suchandra is sitting over there, Principal, Eminent College of Pharmacy. Dr. Partha Pali from Assam Central University will also having a session in this 2 days time conference. My beloved faculty members, dear participants from across various pharmacy colleges of West Bengal. I can see some of my students converted into faculty members in different colleges. They are also here. So I must congratulate all of you to be a part of this event. Yeah, this is the first time we are organizing offline national conference. Our Vice Chancellor has said that it's been 7 years. Why this is first time? First national conference? I said, no, sir. We had conducted one international conference during pandemic period, but that was online, and that was a purely international one. We had a huge success during that time. And I strongly believe the effort taken by the Department of Pharmaceutical Technology to arrange this kind of conference will add value to every individual sitting in this auditorium. As you know that this week, 17th to 23rd, National Pharmacovigilance Week is being celebrated throughout India. This is the 3rd time we are celebrating. It is basically to record the side effects of drugs and to ensure the drug safety. That's why I expect that a session on pharmacovigilance should also be included, because our convener of this conference is from pharmacology department. So I believe that some session will be there. Secondly, that on 25th of September, World Pharmacist Day is coming, and that is also a day to celebrate the pharmacy department. Now, these celebrations are going on since 2016, but formally this national conference we could arrange at a later time. My hope that in the coming days we'll be with a good and bigger conference. Very soon we are planning to arrange one international conference in the month of February 2024, and we are progressing in a faster rate. Now, coming to this today's conference, it's all about the modern strategies to treat the life-threatening diseases. So, as Professor Vishwajit Mukherjee said, that the last century was the development of allopathic medicines. So, this century is for artificial intelligence. And in our pharmacy discipline also, So previously we had a paper on application of computers in pharmacy, but nowadays we are developing a syllabus. We have developed one syllabus, and we are offering. We will soon be offering it in terms of evaluated course to our students. It's named as AI in pharmacy, the application of artificial intelligence in pharmacy. So we learned about drug delivery systems, carrier-mediated drug delivery systems. Now it's AI-mediated. So we are putting one chip or one sensor so the drug can be accumulated exactly at the site of actions, so that the doses can be minimized and the side effects can be minimized. So yeah, as I said that I'll not take much of your time. I congratulate the speakers, and I strongly believe that there will be some takeaway out of this 2 days conference. Thank you. Thanks a lot.
Thank you, Maji sir. Now at last, we are eager to hear from the person who is in the behind of organizing this event, this conference for the first time. Dr. Payal Chakraborty, Assistant Professor, Department of Pharmaceutical Technology, along with she is the convener of this conference. Madam, please.
Thank you all here. So firstly, I want to really welcome our dignitaries, our most welcoming the Pro-Chancellor Sir, Dr. Neeraj Saxena, our Vice Chancellor Sir, Professor Bhavesh Bhattacharya, my beloved Sir from Jadavpur University, Professor Vishwajit Mukherjee, and Professor Tapan Kumar Chatterjee, and also Professor Pintu Kumar Desar, and one and only, that is our Dean and HOD Sir, H.S. Maji. I immensely feel very gratified to welcome you all here today in this Aura scientific platform. And I feel, yes, you can take home some good scientific notions and knowledge behind this with these high intellectual visionary ideas. So I don't want to waste much time here today because we are running late of our first speaker session. So I just like to open our e-abstract book so that all the participants can look into the e-abstract book. They can scan it with their Google Drive, which is already uploaded. So on the screen, you can see our scanner, Google Scanner, where all your abstracts has been documented along with our plenary lectures. So you can get it, scan it, or go to the Drive link and you can get our e-abstract book. So I welcome you all again, and I hope you will enjoy our upcoming sessions. Be with us. We want your extensive cooperation and we work like a team. Thank you all. Thank you all.
Thank you, madam. Now we are about to start the session with our first speaker, Professor Swati Vishwas. To introduce the speaker, I would like to call on the stage Professor Pintu Kumar De, Principal, GIC of Kolani, to introduce her to all of our participants. Sir, please. Volunteers are requested to come over here. Student volunteers are requested to come over here.
Gosh. There you go.
It's visible. All of you can see the screen.
এদিক থেকে বদলে বোঝা যাবে আমি একটু টেবিলে দিয়ে দে না ঠিক আছে
May I request Professor Sati Viswas to take her chair on dais, please. Let me welcome you once again in this 2 days national conference. It is my privilege to introduce Professor Viswas before you. And before introducing her, let me tell you that in the starting of our academic journey, for both of us, the academic journey was started from the same college, that is Himalayan Pharmacy Institute, Maji, Sikkim. I think she has also joined there for first time. Her academic career started from there, and I have also started from there. So it belongs to our academic journey as an academician started from the same point. So once again, I welcome Dr. Sati Viswas to our JS University. She managed some time from his busy schedule. Let me introduce her. Professor Sati Viswas completed his graduation and post-graduation masters from Jadavpur University. Then, as I told you, she started her academic career as an academician from the Himalayan Pharmacy Institute for a short time. Then she moved to USA in 2003 to join the Department of Pharmaceutical Science. Then she moved as a research fellow. She received the prestigious Thomas C. Rumley Fellowship to join the doctoral program. After completing her doctoral study in 2008, she joined the same lab as a postdoctoral fellow. Then after 1 year, joined as a postdoctoral research associate in the Center for Pharmaceutical Biotechnology and Nanomedicine, Northeastern University, Boston. Then she again chose academia. She started her career. Again, she came back to the academia as an assistant professor at BITS Pilani, Hyderabad unit in 2013. In 2018, she was promoted to associate professor, and last year she has been promoted to the professor in the Department of Pharmacy. Professor Viswas received the honor of serving as an editorial advisory board member. Actually, it will take a long time to introduce her. So briefly, if I tell you, she has been engaging in many journals, reputed journals, as in the advisory board member, as an associate editor. So, and she also received the DBT BioCare Award in 2013 and travel grant from ICM. I'm making it very brief, if you don't mind. Professor 115 publications and 13 Indian and 2 US patents. It's a big biography. So already we are running late, and I am I apologize for making her introduction very brief. And from the next time, as we are planning for the international conference, last time when I attended a conference, there I have seen one clock is showing there on the screen. So request the organizer. So if you can program like this, so that it will not be problematic for, because already we are running 1 hour late. Maybe towards the end of the program, maybe 1 or more than that will be late. It will be difficult for all of us to reach home at time. So that's why, if it is possible, because it is very sophisticated instrument and screen displays the time and it hits the speakers also to finish by that time. It's a countdown time. When it 0 comes, it gives barter. So that may be a very smart idea. She has written 12 book chapters and presented papers in 112 conferences. So many conferences you have attended and you have presented lots of papers. So again, I'd like to mention that the lab where she has been working has been funded by DST, DBT, ICMR, IISC, CSIR, whatnot, even Sun Pharmaceuticals. And very interestingly, and one thing till end, that she has been in the list of 2% scientists. It's a very honor for us also that she has been in that. So I think we are very privileged to have you, Dr. Viswas, on the dais, and we are eagerly waiting for listening you. Thank you.
Thank you, sir. I'll ask you to stay back to welcome our speaker, Professor Swati Krishna. Volunteers and request. Let's welcome her with a big round of applause, everyone. Thank you, Professor Viswas, for giving your precious time. Thank you so much, ma'am. Thank you, sir. Thank you, ma'am. Thank you so much. Now the stage, please.
Good morning, everyone. I'm extremely glad that I came here, and it's like a home, coming home type, because all of this around me, I know all of them, and of course, as Pindruda told, we started our professional journey in 2000. And right after completing our MPharm, and from 2000 to 2023, the platform changed, and we are on the same platform again. So it's really a very exciting moment for me. And of course, I know all your professors, Himanshu, who is my junior, and all of them, and also Professor Sengupta. So when I joined this Himalayan Pharmacy, Professor Sengupta was the principal of that college. So and from there, bits and pieces we learned, and that actually is inculcating, and what I am today is because of all of this. So okay, so with that, let's start to the science. And I hope that today, after end of this session, I should able to inculcate some of these ideas to you, that research is a great option. And as your previous dignitaries on dais said, that you can start thinking about it at any time, any point, and you don't really need to think about how to do it. So you will just, the idea is what is important. So let me go to these advanced systems that we do in our lab.
It will help. I mean, economy. File. Sound to body sound does that sound the maximize করবে একটা নব আছে দেখুন হ্যাঁ
Hello.
আচ্ছা ম্যাম স্টার্ট করে দাও আমরা করতে হবে হ্যাঁ এবার ঠিক আছে ঠিক আছে তো এটা এতে ছিল বক্সে ওই ব্যাগে ছিল হ্যাঁ
Hello. Hello.
So the title of my presentation today is Advanced Therapeutics Targeted to Cancer and Ocular Diseases, Hope in the Horizon. So basically, I'm coming from BITS Pilani Hyderabad campus. So just to give you a little introduction about the BITS Pilani. So we have three Indian campuses. One is in Pilani, the other one is in Hyderabad, and we also have a campus in Goa, but the pharmacy is there in Pilani and Hyderabad. So this is the academic build, like this is the main academic building, and this is where our university is which is sprawling over 200 acres of land, and we all live in the same campus, students, faculty, everyone. And as because outskirts, so we don't have anything to do, go for shopping in the weekends and all that. So what we do is only research. We think about research and do the research. So somebody from the dignitaries told that you come to such a level and that then nothing actually matters, that you don't want to do any research or anything. So I try to inculcate is that karma is the main thing. So you should focus on what you are doing. So we do that all the time, every time. So this is just to show you that it's our auditorium, one of the biggest auditorium in Asia. And so we always show it to people. And this is the ranking. We had we are third in 2023 in pharmacy. So this all we want to show. And this is the just a glimpse of our infrastructures. We have mostly everything for high-end physicochemical characterizations, and so we have, and also on top of it, we have the central animal facility, and we have in vivo imaging, so everything we have, so no boundary for that matter. And so this is the nanomedicine research lab that I own, and we do several analysis and several development of the formulations. And how we basically we prepared many different type of advanced nanomedicines, and we test them in many different systems, go all the way to animal models, and find out their biochemical characterizations. So coming to this, what are the current approaches that we take in our labs? So as I said that we work on two different diseases. One is cancer, one is ocular diseases. Now, let's start with the cancer. So cancer, as we already know that there are different drugs available. So we know about paclitaxel, doxorubicin, so many other cisplatin, so many other cancer drugs. But you also know that what kind of side effects they give. So you will, you must be knowing that when somebody is suffering from cancer, they don't die of cancer. They die mainly of the side effects of the cancer, and also the detections are very, very challenging. So you see that a person is getting a good response to chemotherapy after the second round, maybe the third round, suddenly the heart blockage, the cardiac symptoms and all get so severe that the patient dies. So we tried that the nanomedicines can have tremendous potential to decrease the side effects. So if you, some of you are in the advanced, in your undergrad studies, maybe in fourth year, then you will relate to what I actually mean about that. So these conventional systems have a lot of side effects, and which are taken care of by the advanced formulations. Okay, so what are the taken care of? Only the side effects. That is like, we take care of the side effects majorly. And so this cancer targeting is the main thing, like how it can to only cancer, so that other systems of the body is not getting affected. So this is there. Then we have the chemophotodynamic therapy. So these are the new concepts that how we can utilize the light as well as the chemotherapy. So chemotherapy means the drug, and photodynamic therapy is the light along with one agent we call as a photosensitizer. Okay. And then there is a combination therapy. So you see that the combination therapy is always there for cancer, but it is in the conventional form. But how we can make it in the nano formulation so that we can do. And another very emerging thing which is coming and is the chemo photothermal therapy. So photothermal is something that we apply some medicines and we put the drug, we apply some medicines and we put the laser, and then there will be heat generation in that particular area. And that heat basically goes beyond 42 degrees centigrade, so beyond 45. And we have some systems that actually brought the temperature to 80 degrees centigrade. So localizing in that area is like 80 degrees centigrade, it will almost kill all the cancer cells. Okay, so this is what we are actually doing now. And I will also briefly touch upon this ocular therapeutics where we are using the 3D printing approach. And 3D printing approach has a personalized medicine therapy, because you can have the drug loaded based on the patient's conditions. So this is about the bacterial system that I will talk about. So so now coming to so what are the different what are the different formulations that we have tried so far? So if you think about curcumin is something that is a natural wonder, and it's indigenous to India. And when I first came in India, then I thought that we have to do something which will be inexpensive. And of course, for that matter, some of the drugs are so expensive, like paclitaxel or doxorubicin. So those are expensive drugs. And if you think about curcumin, it's not that much. And curcumin is like a wonder because it has so much of other effects also, like it's anti-inflammatory, it's anti-cancer. It has so many other properties which are not even explored. So if we don't explore, then none of the other people, like not the Western country, will explore that in that detail. So I was just listening that that we still have the tuberculosis. The reason because the disease is still lingering is because that the Western countries very much stopped working on this disease, because they don't have much interest in this, because they don't have this disease. So in USA, they don't have a single patient with tuberculosis, and you will be surprised that they don't give even the vaccine to the children for the tuberculosis. So when somebody is born in USA, so they will not have the tuberculosis vaccine given. And but in India, that is the first dose that is given to any newborn babies. Now, when they are coming back to India, they have to take that vaccine. Otherwise, it's not there. So this is how the country have progressed, and and this is where we are. So definitely, if we don't treat or we don't do the research on that, then I think that it will be there forever with us. So this is how the situation. Now, I started working on curcumin, and we made several of the nano formulations on that. Then we worked on doxorubicin as well. So doxorubicin has a huge cardiotoxicity. So this is a very good drug. It has a very good potential to kill the cancer cells, but it has a tremendous cardiotoxicity. Now, why it is? Because it's a hydrophobic drug, and it gets accumulated in the cardiac muscles. So it's causing the toxicity. Then comes to the paclitaxel. Again, paclitaxel is also a natural wonder, but it is isolated from the natural source. But the problem with paclitaxel is that it's very, very insoluble, right? So very, very insoluble drug. And then the problem, and we have to get a way to solubilize. Now, the drug which came, the formulation came is a Taxol, but the Taxol has 50% of the Taxol is ethanol and chemophore EL, which is nothing but a surfactant. And whenever the surfactants are used in our body, then it will cause huge hypersensitivity reaction. The patient had to admit to the hospital. Before giving the paclitaxel, they have to take for 2 to 3 hours of anti-inflammatory drugs to avoid that kind of side effect. So it's not a good option. And then what came in the market, the first nanomedicine for doxorubicin to nullify the side effects is the Doxil or Lipodox. So Doxil was from Johnson & Johnson, and it reduced the cardiotoxicity at that time a lot. And based on that, the Lipodox came in the market by our very own Sun Pharma, and that made this company come to the highest revenue generating company at that time. So this is because of the only success that they could make the generic of that doxorubicin. So that was, generic version of the Doxil, which is Lipodox. Okay, so, and after that, there was another remarkable breakthrough in nanomedicine is the paclitaxel loaded nanoformulation, and which was again a very good discovery, because scientists have found that if you take the human serum albumin and add the paclitaxel in that, it is basically binding in such a way that it is making a nano-sized vesicles, and that is doing the wonder. So you don't need any other excipients to make these nanoparticles. So sometimes these toxicities come because of the polymers used, because of the surfactants used, but this one is something that did not need any other things, only human serum albumin and paclitaxel. So that was a very good discovery, and of course we know that the major transport protein in our body is human serum albumin. So there is no toxicity for that, but it actually increased the solubility of paclitaxel a lot, and again the targetability also improved. So these are the two different nano formulations that came in the market. And that is the only two for cancer so far available. So you understand that there is a lot of research gap that we can address by this. So as I said, that we developed various curcumin formulations, and so initially we started making with the lipids. So cholesterol is one of the lipids that we used, and we actually made it then we used the chitosan. In my lab, we actually make a lot of polymeric systems we take and modify them with the drugs. So we basically use the xanthochrome stabilized pegylated gold nanoparticles. Gold also is a very high potential, so a lot of good effects are there for the gold nanoparticles. So we try to have these loaded with the curcumin. Then we also did some studies with, some of these delivery systems which causes the multiple drug resistance challenges. So we also do that. Then chitosan cholesterol micelles are used. Then we also used the albumin. Now here we try to make a modification of albumin with the lipid. So we call it as a lipoprotein, which is made outside. So we have the human serum albumin, which is a protein, and we conjugate it with the lipid just to make the greater cell assembly potential. And we saw that if we use the human serum albumin only, or we use this lipoprotein combination, then lipoprotein has more power to load the drugs. Okay, so those kind of systems we have prepared. For doxorubicin delivery, we have again used several systems. Then we have also started using one polymer, which is poly-DL lactide. And of course, this is a very biocompatible polymer. So my initial approach was that, again, as I said, that inexpensive formulation. Now, if we are using lipids, then lipids are expensive, liposomes are expensive, and that's why doxorubicin loaded liposomes are expensive. So I wanted to see that if we can use the polymers and which we can make a bulk amount and that can do the same job. So we started working on poly-DL lactide nanoparticles. Doxorubicin delivery, again, we wanted to take a combination approach. So we see that if we have some vitamins, we incorporate it along with that, then it actually gives some of the good effect anti-cancer action. So, so what are the vitamins that we can use is like a hydrophobic one. So vitamin A and vitamin D was used extensively for our research, and we have seen that also vitamin E as well. So vitamin E has very good potential to inhibit the multiple drug resistance. Now this is a new term that I'm bringing to you. Multiple drug resistance actually occurs after the first dose, because sometimes you will see that the patient is very much responding to the first dose of the chemotherapy, but after a few days they are not responding well. Now why? Because the cancer cells are developing some of these receptors to take the drugs out. Okay, so this is like peak lipoprotein expression. Now we have seen that the vitamin E actually is reducing that, so reducing the level of peak lipoprotein. Okay, so this was effective. Then we also did the medicine delivery using human serum albumin nanoparticles as well. So all these studies again for paclitaxel, we made some conjugates. And we use one system which is known as dendrimers. So this is a big polymer. So we also have used that. For paclitaxel, again, we have used that polymeric system as well. So these are the few studies we have done. We have also used the cell penetrating peptide. So then we wanted to go in detail that how these particles are going inside. So we tried to attach some of the cell penetrating peptide octa-arginine, and then at how the effect of internalization is happening. So again, the docetaxel delivery as well, we also started looking into the docetaxel delivery. Then our goal was to work on oxaliplatin. So oxaliplatin is basically, unlike the other drugs, oxaliplatin is highly water soluble. So, but again, this drug is very effective, but the only problem is that it has a tremendous side effects, which is nephrotoxicity is one of them. And so, but even though this is very potent drug, so what we did is basically we made a kind of a system where we published it recently in 2021. So this one basically we made a system where we took the chitosan polymer, and then we actually put the chitosan, we modified the chitosan with the this one vitamin E. We tried to load the chitosan and load the oxaliplatin, and we got the good success in that. Then we also did some work with another drug which is known as a PARP inhibitor, very recently approved drug, olaparib. So olaparib is basically approved for BRCA1 mutated cancer, breast cancer. So where we see basically it is inhibiting the DNA replication, and in case of some disturbance in the DNA, some other genes get activated and comes in the repairing process. But if that is also mutated, then this drug works wonder. But we actually showed that this can be used for the solid tumor as well. So the simple formulation that we have used is human serum albumin just binding to olaparib. So we have done that. And then, just to give you a brief background about photodynamic therapy, as I said that photodynamic therapy is light. So you have to first administer, and then in damp condition, the patient has to put targeted laser. So that laser will activate the drug. So that laser will activate the photosensitizer, and there will be huge generation of reactive oxygen species. And that reactive oxygen species will kill the cancer cell. So this is what is the idea. But if the photosensitizer goes everywhere in our body, and you expose or not exposing them properly with the light, then tremendous toxicity will be generated. So photodynamic therapy is available in the clinic. They are used, successfully. But our goal is to make a nano medicine, nano formulation of that, which has a preferential accumulation in the tumor. So we actually made that kind of formulation, and could find a good success for that. So we have the other ways to do this. We do get the polylactide formulation, and then we could get that. For C6, we have done few of the studies and delivered that chlorine E6. Then we actually started thinking about how we can go in the molecular level and what is really happening there. Now, if you see that tumor which grows and grows and grows in a huge proliferative, and then what happens that the inside cells, they become very much deprived of oxygen. So you see that the growth is mainly happening in the outside, the periphery, but inside the tumor cells, they are necrotic, they are dying, and they become very, very resistant to all the treatment therapies. Now, when we see that in the first treatment of chemotherapy, the patient responding well, the tumor volume is shrinking, but that after certain time, it is not shrinking the way it should, and it is not eradicating it. The reason because of this production of the cancer stem cells, and which are residing, and they are hugely resistant to the drug therapy. Now, what we can do here, and we can actually oxygenate them. Now, how we can oxygenate them? And oxygenation actually increases the potency of the photodynamic therapy, because you are generating the reactive oxygen species, and for that you need oxygen in the cells. So what we do is we made the nanomedicine in a way that it will deliver the oxygen as well as it will deliver the drug. Now, for that matter, we took some approach that so basically we took an approach that we made a polymeric system. So again, we use the PLA. MPEG is required because of long circulation. If we don't pegylate anything, then it will just be cleared from the by the renal excretion. Now we have to make all the nanocarriers. We have to make pegylated. So other than that, it will not be long circulated. So we make this PLA, and then C6 was incorporated in that, and we have found that this PP4 diazide group is basically liberating the oxygen from the nearby hydrogen peroxide. So it is basically using the excess hydrogen peroxide to make the oxygen, and which is causing the alleviating the hypoxia symptoms. So we have done that, and then we could see that basically that which was actually hypoxic, then that causes the oxygen production. And we actually did some of the studies to there is oxygen oxidation green we have tried, and we see that this is basically the presence of hydrogen peroxide gives a green color, but hydrogen peroxide is transforming to oxygen, so we could not get the green color, the color retaining. So oxygen is getting produced. And we also see with the oxygen generator that oxygen, how we can measure the oxygen, and we can see that, yeah, it is actually generating the oxygen. And we did several, these are the routine experiments we perform. Any drug comes, we see the cytotoxicity study. So we check that how, what is the IC50 for that, if we can reduce that IC50. So IC half maxima, you already know that how the 50% cells are getting inhibited or killed. So we could get that. Now we see that they are getting reduced with ours. So if you see the free drug, which is 15 microgram per ml, but we see that our formulation is causing it to 10 microgram per ml. So this is then again, if you see that, but with laser, we could see even more down regulation. So that means that the laser treatment actually working for the photodynamic therapy. So this is also a routine study that we do in our lab. We generate the tumor in animal models. So in mice model, we generate the tumor, and we see the over the time with the in vivo imaging facility that how the tumor is regressing. And after that, we collect the tumors and see that how the tumor volumes reduced. And then we collect the tumor and do the histopathological analysis to see the toxicity in other organs. So this is the routine study, and then So for this study, we said that photothermal is important, emerging field of research which is happening. And for that, we have chosen a very inexpensive compound, which is graphite. So we have taken graphene oxide as the platform to deliver the drug, and which is also have the photothermal effect. So this is how the structure of graphite, which is aromatic, polyaromatic structure, and we can use a method which is well established in the literatures, and we can make this graphene oxide, which will be having a lot of carboxyl acid groups on the surface, and then we modify them with the MPEG PLA. So the reason that we are modifying is because we want graphene is inorganic, it can have some toxicity, but when we add that MPEG and PLA, we make it like a biocompatible. So that's very important when we are using something inorganic for that matter. So then after that, if we see that it is loading the doxorubicin a lot, and you can see here that this is the scanning electron microscopic structure, that we see that the graphites are having like a sheet-like structure, and graphene oxide again it's a sheet-like structure with not so much of thickness. And when we put the MPEG PLA in, then it became like the spherical kind of structure. So which is really great that we could make from the sheet to nanoparticle, spherical nanoparticle-like structure by surface modification. And this is a glimpse of our in vivo study for that. And the tumor volume, if you can see that we started from the 50 millimeter cube tumor volume, but which did not get up after that. So it was like we could reduce the tumor volume progression, but then you could see that the control without treatment went to up to 1100 millimeter cube. But our treatment actually reduced it a lot. So you can see that this is a control tumor, but which reduced to almost very low. And both of the treatments are given by at different doses of laser, putting the laser. So this is what we could do that. Then also we checked in the level of metastasis, and we could see like after the tumor comes to the primary organ, and then after some time it gets metastasized to the secondary place, which is mainly lungs or brain or any other parts of the body. So lungs are the main part that metastasis happens. So what we did that we generated the tumor, we took that tumor off and surgically removed the tumor and allowed the mice to grow, to come back to life again. And then we observed them, and then within 10 days, they developed the metastasis. So metastasis must have been initiated within 21 days, that we find that the metastasis has been developed. We could see that this red sign that you are getting is the metastasized tumor cells that you saw. But you see that there is nothing present in our formulation. So that actually they took care of that. So this is how we basically we have done the study, and we have taken the tumor lungs out and did some of the studies like lung weight and all the markers. And this is the photothermal study that we have done. So you can see this is there is a NIR IR camera. So we can IR camera detects the temperature. So you can see that this is the mice that we have taken, and it went up to 53 degrees centigrade over here. So you can check that. You can see that, and very focused, light can heat it up. So with the graphene treatment. So this is one of our unpublished work, and we are very hopeful for that. And now here, what we have done is we have used the manganese peroxide nanoparticles. So we have, because they have the inherent ability to generate oxygen. So MnO2 produces oxygen, And we also have seen that MnO2 is a good contrast agent also for the MRI. So we can actually have a theranostic application. Then we have also used one of the polymer which is known as polypyrrole. So polypyrrole has tremendous photothermal potential. So we could see that it actually increased the temperature to almost 84 degrees centigrade. And then as because it's a nano system, we could also load the drug there. So that is also another great thing that we could do. And this is some of the studies that we have performed about the photothermal efficiency. As you can see that it went all the way to around 87 degrees centigrade and a huge photothermal efficiency that I think 94% photothermal efficiency. It's, I mean, we haven't seen anyone reported it so far. So we could achieve that with our formulation, and we are still doing it. And this is a three-dimensional tumor that we grow in the ex vivo system. Like, I mean, I will say that we take it from the monolayers and cells and make it in a spherical form in the laboratory condition and try to check some of the markers. So this is we did. And here you can see that our animal study showed that within day 10, the tumor is almost shrinking, and you can see that the control has a big tumor and which is progressing to even bigger at their age of 21 days. Okay, and but you see that here the tumor is regressing and then it got vanished after 10 days, and we could not collect any tumors after 21 days when we are sacrificing the animals. So we could see that photothermal has a huge potential for anti-cancer activity. So we could, after that, again the lung metastasis was done, and you could see that these big nodules which are coming from control without treatment lungs, but you could see that this lung is almost fine and healthy and with no sign of any metastasis, and the lung weight did not increase with our treatment. So this is what we have done, and again some of the other formulations we do. We have again it's very important that how the blood biochemistry is changing. So we actually have taken the same analysis of the RBC after treatment, and so this is also one of the steps to see that if they have any effect in samples, and these are some of the studies we do routinely for the biochemical developments and all that. And so definitely all the proliferative markers and ROS generation that needs to be seen. Yeah, so now I will just, so this is all about cancer, but I just want to touch upon the ocular disease that we actually focus. And for that, we take the bacterial keratitis as a challenge. Now, what we basically do is, I will show you this part is very interesting, that we use the 3D printing technology to develop a contact lens like patches. So 3D printing is here in India for quite some time, and it has come with a lot of hype with that. But the thing is that this printing won't take too much time. So the good thing about this is that we can have a personalized medicine. Now, what does it mean? It's like if a patient comes with keratitis condition, but you know that you cannot depending on the severity of the infection, you can treat them. So depending on the severity, you can load the drug in the patch and you can deliver it. So this is what is the good thing. And also you can know that which bacteria is getting infecting this disease. So then you can give the drug accordingly. And the patch is something that it is far better than drop systems, because the drop goes off from the eye and you have to give it on regular intervals. But for this, you don't need to worry about that, because it stays there for some time. So there are a lot of systems like that available, like contact lens, drug-eluting contact lenses, where the normal contact lenses, people load the drug in it, But then unlike that, what we have developed here will eventually be dissolved in the eye and will not stay there. So it takes 8 hours to dissolve that, and then it will it will not be there. So but unlike contact lenses that you have to remove it after the drug goes off, so this is not like that. Now you can see that this is how the bacterial keratitis occurs, and these two are the common pathogens, P. aeruginosa and S. aureus. And you see like something like a green film that develops in the eyes, which is one of the sight-threatening diseases. And what we made it like, it looks like this, and you can wear it like this. So now, what was the composition? We have taken two polymers, which is gelatin and chitosan. So the chitosan is positively charged and gelatin is negatively charged. But if you mix them, they will not going to make a solid, contact lens like support. So you have to do some chemistry in that. So we actually do methacrylyl chloride. We modified it so it became methacrylated. This one also we methacrylated. So these two polymers, when you put them together, you can make this bio ink for that. Okay, and after you make the bio ink, so it will make and you give the system the 3D design of this. You give that command. And then it will make the bio ink fall and make it like a concave type structure of the contact lens. And then you have to irradiate it. You have to give the UV laser so that the cross-linking between all the methacrylate polymers will happen, and that will make it as a rigid structure. Then you dry it, and then you get your contact lens like structure with diameter 15 millimeter, height and thickness that we receive. So after this, we could do some of the physicochemical characterizations, like how mucoadhesive strength is, because it is important that once we put it there, it should stay there. So mucoadhesivity is very important. So for that, we have to make it a little bit on the positive side so that it binds with the negatively charged mucin in our ocular system. So we also do that. Then we check their properties. So here we basically used the antimicrobial peptide. So we actually loaded the drug antimicrobial peptide. Now there is again the reason that why we are going for peptides to kill bacteria when there are so many antibiotics available. Now, as one of the dignitaries pointed out, that the journey of antibacterial therapy started with penicillin. But now that we have a very handful, a few antibiotics to combat these microscopic organisms. So we don't have many, and the bacteria are smart enough, they have developed the resistance. So now the emerging global concern in the medicine field is how to control or combat this antimicrobial resistance. So AMR is the next concern for the whole, whole people, like everyone globally. So this is what, and then we have to look for the alternatives. Now, what are the alternatives? There are so many alternatives that we can think of. The inorganic particles, and also these antimicrobial peptides. A lot of work is going on. So this is one of the work that we have done in collaboration with LV Prasad Eye Institute, and they have developed this antimicrobial peptide. And then, but then their strategy was that this antimicrobial peptide is something that our body actually generates whenever there is a bacterial attack. So this is where from we got this sequence, and then we try to load it, and we see that this is having the among all these gelatin and chitosan combinations, we see that the 50% of them actually is good. And this is the study that we did to check the in vitro antibacterial study. We made the formation of biofilm. The bacteria develops the biofilm in our eyes, and that is the way that the bacteria decide in a resistant manner. So we did that, and we see a lot of red signals, which is from the dead cell populations. So this is how we have done. And this study, in vivo therapeutic activity, was done in the rabbit eye, and we have this is the eye before injection, and this is what you see that before treatment. So we generated the bacterial keratitis in eyes, in rabbit eyes. So you can see that this is how the eye becomes after treating them with the bacteria. So this is really painful to see this innocent animals getting this bacterial infection. So not good for the research scholars, but yeah, we did for a noble reason that how we can alleviate these symptoms, and then after treatment we could get that haziness gone and the transparency is coming up. So we could get that. But if you see that only free drug do not have that, you can see that it is working, but not as good as this one. So this is just because the nano populations have the good potential. So this patch actually sustaining the drug release. This patch actually helping to release the drug, stay in the cornea. And we can also see the CFU count, which is colony forming unit that we homogenize after the treatment. We sacrifice the animals, we take the rabbit eye, and then we homogenized and plated for the bacterial count. And we have seen that this has a very less bacterial count compared to all other groups that we have seen. So this is a very small background that I have given on our antibacterial work. So right now the nano has tremendous possibilities, and we all have to explore the field so that we can actually alleviate some of the symptoms. So now you can see that the Volini works for the pain treatment, but NanoFast works like a wonder. Now, why it is happening? A single change in the formulation that's making it in the nano system, which is penetrating better and taking up. So this is basically we have to bring that not just in cancer, in all other diseases, in a most possible, the best possible way. So that it is not nowadays only restricted to having the spherical structures. It's also going towards the asymmetric particles, and we call it as a Jenna structures. And this is like, the very, very, recent discoveries, and people are working in a very recent way. So our lab, we got a funding from Indian Institute of Science very recently to work on to make the Jenna structure, which we called as a nano flask. So nano flask is something which will be like a flask. And we are not there yet, but we are almost there. So we see that our flasks are forming, but we just need to have a little name on that. And this is how they are looking. This is how they are actually. So you could see that these are the spherical things. We all make the spherical particles. Nanoparticles are probably now many scientists are working in this field. But how about the Jennas? How about the asymmetric particles? We are not there yet. But if you see the science behind it, this is all about how you are making the two surfactants. One is highly hydrophilic, the other one is highly hydrophobic, to play around so that they will try to escape and will make a hole and will make a structure like a flask. And this is the same structure, scanning electron microscope structure, where you will not see what is getting inside. But as I said, that we are just exploring this, and you will see that this structure has a hole inside, and you can actually do so many things. You can actually load the box. You can actually make something like a bullet kind of thing. Okay, now how you can do that? We have to research have shown that if you put something like oxygen, then if you generate something in the there in a stimuli sensitive manner. What does it mean? Let's say that you put this, somebody eats this, and then it goes to the stomach environment, which is pH 1 to 2. Now, if it goes to 1 to 2, in presence of enough of this hydrochloric acid, if you put a platinum over here, then it will produce the hydrogen gas. So it will make the bubbles. So you can utilize this environment. So whenever it will be like a rocket. So they call it as a nano rocket. So you can put the gas will be coming out from here and it will give a propulsion. So immediately it will move like this and it will go everywhere. And if somebody is having like Helicobacter pylori infection, where it is difficult to penetrate the mucus and go deep in the tissue, you are giving the propulsion ability to the particles so that they will go to that, they will penetrate that mucus. So you need that propulsion ability. So in next 3 years, we will be working a lot on this by receiving this grant from Indian Institute of Science. So this, what is, but we are not there. As I said, that we just have to increase this a little more, and we will be able to do it by making the different combinations of the surfactant. So we are very excited. The whole lab is excited to see that whether this is getting more or not. So this is where it is. And if you see this structure, so I'm also right now intrigued with all these different structures that the nanoparticles can make. So this is called the zinc nanoflowers. So, so if you see under the scanning electron microscope, you see that this kind of flowers are forming. And if you use the nitrate, this kind of flowers are forming. If you use acetate, this kind of flowers are forming. For 3 hours, 1 hour, you can see that. So this is because of they are crystallizing. So materials has a huge impact. Now, if you see how much surface you are increasing from the nanoparticles to these flower systems. So it's a huge, if you think about one nanoparticle which is a spherical and having this shape and something which is having so many of these flowers coming out, you are increasing the surface area many-fold. So that has a tremendous impact. Now, if you want to add some drugs, it will have very high drug loading. If you want to use them for the diagnostic purpose, it can have a better effect on that. So now it is, these are all very recent. Probably people have started working in 2017, 18 from there. They just started to think about those systems. So this is, with that, I want to say that it all has a tremendous impact, and the research field globally needs energetic and enthusiastic, motivated students and investigators like you all. So you all have to work hard to generate your idea, at this point you have to clear your basics, and you always have to have the understanding of what you want to do in your life. So this is very important, and you get inspired to do something meaningful. And when I was not there, I did not know about this science. I feel like what my life would have been without this. But now that I sacrificed many things, I don't, do, because we have only one life. But the joy that I find in everyday's life doing this is remarkable. So I encourage everyone to do something hard, to work hard, do something, and come to research. And you will be getting the surge in dopamine that you have never got the experience before. Okay, thank you.
Now,
so at least I have a few things left to see. I'm going to summary, but I'll just.
It's a broad area. You have covered a lot of things.
These are the people who basically. Okay, I'll just show you this one. These are the people who worked very hard, and I'm the one who is just representing it. Probably they would have told you much better way. So I want you, some of you, to be here. So, and that's aim for me to come here so that I can get some of the energetic people like you, them, so who can work. And also we do have some fun. So we sometimes go out and have fun. And this is that one of my students' defense, and all of them are, as I have told you here, So these all four are graduated from my lab, and one is a scientist in Chicago in a pharma company, and he is in John Hopkins Cancer Research. He is also in Texas, and Sonia also moved to University of Buffalo. So all of them, and he is going to the University of Wisconsin. So a bright opportunity for them. Thank you so much.
Thank you very much. So for the last 1 hour, we understand the area of our research work, which covered a lot, and each and every paper which she has published may take 2 or 3 hours to understand. So by this 1 hour, she covered the whole research thing she has been doing for last 20 or more years. So please. First of all, she covered about the cancer therapy. We know very recently one of our favorite TV actors. So sometimes we found some good response from the chemotherapy, and after maybe first or second therapy improves a lot, all on a sudden patient may be deteriorated and it may be like threatening, as we have seen, and ultimately we lost her. So it's due to some disease and due to sometimes from the treatment side effects. So their noble goal is to reduce the effect so that the advanced therapy can be brought into the market, and the therapy cost or the cost of life also, the life can be saved also from the, and the new things, new technology they have applied, but we could understand that photothermal, instead of giving only the chemotherapy, it will could add on the photo or light laser effect as well as the thermal effect. That could have been much better for the cancer patient because they suffered a lot in the disease and in the treatment also. During treatment also, they are having lots of sufferings. And another broad area she covered, that is the personalized medicine, that what I was talking about. This is the advancement of the therapy, 3D printing, personalized medicine, gene therapy, and the ocular therapy. Sometimes it happens that, as Sarah has also mentioned, that the blind people can, through some spectacles, the blind people can see. And sometimes some patients, if they lost their, also due to the tissue regenerating, as I told you, that regenerative therapy, through this therapy, we can regenerate the tissues so that his normal vision can come back. So she is again working on a broad area of ophthalmic delivery, drug delivery through that lens or contact lens or some patch which can cure lots of disease and reduce the suffering of the patient. Thank you, Dr. Viswas. I hope we are running late by more than 1 hour. So if you have some questions or query, you can directly mail her or you can contact her through our teachers, faculty members. So should we take question or?
We can take questions.
We can take very few questions. Or if you have any queries, you can raise your hand. You can ask directly.
Yes, if you have any question, please raise your hand. Mike will be, she has it.
Okay, thank you, ma'am, for a very nice lecture. So I find you showed, it was very interesting for me regarding the eye contact lens when you talked about the bacterial keratitis. I just wanted to know whether this lens can be also for a therapeutic application like glaucoma, because it will be really helpful that if the patient suffering from glaucoma, like they can be well treated, like the contact lens itself can be a drug delivery system. Can it be performed in this way?
Yeah, thank you, Payal. Yeah, that's a very good question. Yeah, I think all the diseases related to eye can be treated because this is a delivery platform, and this is basically delivering the drug in a sustained manner. So we have to see that what drug, that maybe that imolol maleate or yeah, so those drugs, like we have to see that whether it is going to the back of the eye, because that's what is important. But yeah, so this will be better compared to eye drops that is there currently. Yeah, so definitely.
Thank you. Anybody else having any questions? So we can give the mic to you. You can ask the question directly. Anyone having any questions? Oh, sir.
Shafii, thank you for your remarkable and mesmerizing presentation. I'm really spellbound with your talk. Just one question from my inquisitiveness regarding your very hot topic of photosensitizing therapy in cancer management. Just for my inquisitiveness, I wanted to know for cancer chemotherapy, cancer management, what type of molecules should be the property, whether it is a photosensitizing agents or we can artificially make it photosensitive to treat the cancer for your nanoformulations.
Yeah, actually, no, you need photosensitizer because not all the drugs have the property to, vibrate. You need photosensitizer, but if you want to make any drug photosensitizer, so then maybe you have to attach body P or something like that, but then that came as a new drug entity, right? So, but there are some things available like Foscan, photosensitizer loaded liposomes. So those are available. Maybe long back it also developed, but now that some recent new photosensitizers are coming, so they are basically, previously it was only UV radiated, but now they are NIR radiated also. So NIR, the good thing about NIR, it can penetrate the deeper tissues in our body, but UV is harmful. So even though they were good photosensitizers, but you can't use them for our body. So, but now it has seen that it shifted, the laser thing has shifted from like 400 nanometers to around 660, because this C6, fluorescence is 660, but you can even get something which is more than that, like graphene oxide, which is photothermal, which is like 808. But if you go like 1000 nanometer wavelengths, then you are getting almost in the IR level. So those have a good penetration. Thank you.
Thank you, Dr. Pali. So let's end this session here. Anything, any formalities?
Yes, we would like to thank ma'am by giving a small gift, token of appreciation from our department. Thank you, ma'am. Thank you so much for sharing your knowledge, your research work with us. Thank you so much for your time. We are really happy and thrilled to have you amongst us.
Thank you. We started so nice.
Thank you, ma'am. Thank you. Speaker sir, I'll ask you to stay back for a while. I would like to call Professor Bishwajit Mukherjee sir. Please come on the stage, sir. We would like to felicitate you again with a small token of appreciation for always advising our department, always being there with our department. Please give a big round of applause for sir. He is the BOS member, Board of Study member of our department, guiding in everything to make our department better, to make the rules and regulations of our department better. to run the department very smoothly. Thank you so much for your continuous cooperation. So much. Thank you, sir.
So I sincerely convey my thanks and gratitude to them. Basically, I am associated with so many institute and organization. I really do not remember I am there. But yes, I am there with this this university. I think I am the POS member. I am other members also. And it's nice. Because I was about to leave. By that time, I have been asked here, and I was actually hesitating to come over here because lecture was going on at the 3 hour of a lecture I am entering. So, and Sati, I know she is a good speaker, but she will mind. But yes, then I really do not know what is the reason. But I sat there almost. I just had a couple of last minutes discussion, and then all of a sudden they have offered me this. But Goddess Durga, it's the right time I got it, because as you have got, other speaker will also get. Thank you very much. Thank you all.
Thank you, sir. Now we are at the session. We are at the time of the session where we have already our next speaker, Dr. Shonti Mukhopadhyay, and we'll continue with our session, obviously. And by the meantime, if any one of you want to go outside and have tea, you can, but the session will be continuing. So you have to go from the back door, you have to come back once you're finishing the tea. The session will be going on. To introduce and to welcome our speaker, I would like to call on the stage Professor Kamalakanta Roy, sir, Professor of our department, to felicitate our speaker, Dr. Shonti Mukhopadhyay. Sir, please. Shonti, sir, please come on the stage.
Good afternoon to everybody.
Sir is requested to come a little bit in the front to get felicitated by our Professor Kamalakanta Roy, sir. Please give a big round of applause. Please give a big round of applause to encourage the session. Thank you, sir. Thank you so much.
So, good afternoon. So it's our great pleasure to have with us Dr. Shonti Mukhopadhyay. In spite of his busy schedule, he has consented to share his experience with us. So it's a brief introduction about Dr. Shonti Mukhopadhyay. He is a scientist, Deputy Director, Council of Medical Research, National Institute of Cholera and Enteric Disease, Kolkata. He is MD in Pharmacology, Fellowship in Palliative Medicine, FMER Fellow, University Gold Medalist, and topper in Pharmacology during MBBS study. A passionate teacher and a clinical researcher, and received 7 international awards, including Young Investigator Award in USA from the Multinational Association in Supportive Care in Cancer, first time for a medical pharmacologist. He has more than 30 publications including some international guidance, document, and book chapters. A response person for more than 40 national and international conferences and workshops, and after 20 plus years in medical colleges in different faculties, he joined ICMS in 2021. Member of multiple of ethics committees in different capacities, including basic scientist, chairperson, and member secretary, research interest or supportive care in cancer, antimicrobial stewardship, pharmacogenomics, applied psychometry, and digital health and pragmatic clinical trials. So I welcome again Dr. Sandeep Mukhopadhyay. Sir, please, the platform is yours. Now we can start.
Thank you for the kind words. Hello. So thank you for the kind words. Last speaker, it becomes difficult to talk after the excellence of the last speaker, which was enlightening to me. And I heard that she is well known to everyone in this institute. And unfortunately, I am known to no one. So starting from zero, so maybe after the presentation, you have to remember me. Or you will forget me.
Yes. No.
So probably you have to remember me for the next 1 hour torture before your lunch. So sometimes it happens. At a conference, so I think everyone knows Bengali. Sabai Bangla jane to?
Hi, sir.
Sabai Bangla jane. ঠিক আছে একটু একটু বাংলা মাঝে মাঝে বলবো। তো কনফারেন্সে একজন স্পিকার উঠেছেন বলতে, দেখা গেল হল ফাঁকা, মাত্র 3টে লোক বসে রয়েছে। তো 3টে লোকের মধ্যে দুজন হচ্ছে যারা চেয়ারপারসন, আর বাইরে একজন লোক সে খুব গম্ভীরভাবে শুনে যাচ্ছে। তো সেশনটা শেষ করার পরে সেই স্পিকার কি করলেন, সেই ভদ্রলোককে খুঁজে বের করলেন, করে বললেন যে আপনার এত ইন্টারেস্ট সাবজেক্টের প্রতি আমি সত্যি মুগ্ধ হয়ে যাচ্ছি, যে এত ইন্টারেস্ট নিয়ে আপনি আমার লেকচারটা শুনলেন। তো আপনি কি করেন, কোথায় আছেন, আপনার সাথে কি আমি কোলাবোরেশনে কিছু কাজ করতে পারি? তো সেই ভদ্রলোক জবাব দিলেন, মশাই আমি মাইকওয়ালা, ডক্টরটা শেষ হলে আমি মাইকটা গুটাবো, সেই জন্য আমি বসে আছি। তো যত বেলা হয় তত সেরকম অবস্থা আসে, একটা প্রি লাঞ্চ মানে সেই মাইকওয়ালা থাকবে, এরকম একটা অবস্থাতে হয়তো বলার মতন অবকাশ আসবে। তো লাস্ট দুজন স্পিকার যাদের সম্বন্ধে জানলাম, যে হিমালয়ান ইনস্টিটিউট মাজিটার যে জায়গাটা আমার যাওয়া আসা ঘোরা বেড়ানোর জায়গা হিসেবেই ছিল, বাট বেসিক্যালি আমি হিমালয়ের খুব কাছাকাছি জায়গা থেকে আসা একজন মানুষ। আমার জন্ম ছোটবেলা সবই কেটেছে উত্তরবঙ্গে। তারপরে এক সময় ডাক্তারিতে চান্স পেয়ে ডাক্তারি পড়তে আসি। পরবর্তীকালে একটা সুপার রিমোট এরিয়াতে চাকরি করতে গিয়ে নাজেহাল হই। তো যেখানে আমি ডাক্তার, আমি নার্স, আমি ফার্মাসিস্ট, আমি গ্রুপ বি, আর প্রতিদিন সেখানে 2 কিলোমিটার পায়ে হেঁটে যেতে হতো। রেল স্টেশন থেকে নেমে ট্রেনটাতে বোধহয় আমি একলা টিকিট কাটতাম, আর স্টেশন থেকে একটা প্ল্যাটফর্ম আর অন্যদিকে লাইন, সেই লাইনটাতে নামতে হতো। যদি ট্রেন ওইদিকে প্ল্যাটফর্মে থাকে, মানে ওইদিকে প্ল্যাটফর্ম নেই, লাইন থেকে ট্রেন থেকে নামতে হবে লাফিয়ে, তো যদি লাফটা জোরে হয় তাহলে কিন্তু পুকুরে গিয়ে পড়তে হবে। তো এই জায়গা থেকে আমার ক্যারিয়ার শুরু। পরবর্তীকালে আমি মেডিকেল কলেজে আসি। একটা সময় I was a full-fledged practitioner of critical care, anesthesia, and also surgery. Sometime in my life, I got very much inspired by someone, and that day I decided I will move to a place where I can learn pharmacology further. And I left West Bengal with that vision that I will take torture of another 3 years for my MD from a premier institute. So I went to Christian Medical College, did my MD in pharmacology. Then I did a fellowship in palliative medicine because that was the nearest discipline to
supportive care in cancer. I developed some interest in that area because this is some area of research where pharmacology merges with the clinics. We do pharmacovigilance. We collect data of side effects, but what to do after that? If we don't treat them, if we don't have the answer to those side effects, it becomes useless. Supportive care cancer deals on those areas. So it deals with chemotherapy-induced nausea, vomiting, it deals with neuropathic pain, it deals with many other side effects. So anyway, তো যে কাইন্ড ইন্ট্রোডাকশন গুলো স্যার দিলেন সেগুলো তো আলাদা ব্যাপার ছিল, ভালো ভালো কথা। আমি একটু আমার দেশি স্টাইলে কিছু কিছু ইন্ট্রোডাকশন সবাইকে দিলাম আমার সম্বন্ধে, বিকজ ইট ইজ ফর দ্য ফার্স্ট টাইম ইন মাই লাইফ আই এম অ্যাড্রেসিং এ গ্যাদারিং অফ এ ফার্মাসি কলেজ। So please start the presentation. I can see many faces who are pained already with hunger. So perspectives in clinical research in modern Indian pharmaceutical environment, I was told by Payal madam a few days ago that you can choose any one of these topics. So I thought that I should talk about this perspective of clinical modern clinical trial. So basically, all the opinions being shared here are my personal and not belongs to my employer, ICMR, Department of Health Research, or Government of India. So this is purely on me, and some of the slides contain some pictures which are collected from internet for academic purpose only. With this disclaimer, I start my session. So we will discuss about the brief background of today's lecture, the need for the clinical researches, phases of clinical trials, platform for a clinical trial, an Indian platform in the form of ethics, regulatory platforms, and others. And finally, it will summarize. Okay. So, can anyone tell me which is the place? Last jara acho, বেড়াতে টেড়াতে যাও তোমরা কোথাও? যাও, এই জায়গাটা কোথাও দেখেছো? ছবিটা দেখা যাচ্ছে? দেখা যাচ্ছে। ওকে। এটা কোথায়? কিসের ছবি? কোথাকার ছবি? Anybody? আরেকটা হিন্ট। তিনটে ছবি জানা গেল? আরে একটু বুদ্ধি লাগাও, যদি না পারো তাহলে একবার করে গুগল লেন্সে সার্চ করে দেখতে পারো। You have the technology with you. Last hint. আর তো জায়গা নেই এই স্ক্রিনে। তো অনেকেই দেখতে পাচ্ছি যে তোমরা এবার অলরেডি গুগল লেন্সের বুদ্ধিটা শুরু করেছো, ছবি তোলা শুরু করেছো। This is nice. So this place, the name of this place is Dachau. This is in Germany. So Dachau, Germany, এটার সাথে আজকের আমার লেকচারের কি সম্পর্ক? আবার এইখানে এই ছবিটার মধ্যে আবার লেখা আছে never again. This is again picture of Dachau, Germany. Do you know what is the context I am going to tell? Any idea? No idea. This is the picture of the place which I had shown earlier. This place. This is the same place. This is the same place. And there is a huge number of people who are gathered here. Why I am talking about this Dachau? Dachau is famous for a concentration camp. Do you know what is concentration camp? It is a form of a prison. It was established in 1933. Dachau was the first regular concentration camp established by the Nazi government. Hitler's নাম শুনেছো সবাই? নিশ্চয়ই শুনেছো। তাহলে হিটলারের আমলে এটা এস্টাবলিশ হয়। কি হতো এখানে? Among many other things, this camp was famous for many of the infamous experiments, medical experiments, from which science got benefited, but personal rights were violated. So beginning in 1942, in this Dachau camp, they conducted, the doctors, they conducted some trials there, like high altitude experiments, like hypothermia experiments. People were kept in hypothermic conditions till they died. They were allowed to die. It was a form of killing. Why? The scientists wanted to know how the death is occurring. What are the changes in human body with this type of conditions? They were put in the high altitude to see how the people are dying in high altitude pulmonary edema or cerebral edema. So these were the place, Dachau concentration camp, where such atrocities were done. Hundreds of prisoners died or were harmed as a result of these experiments. And during this 1933 to 1945, in these 12 years, almost 2 lakh people were put in this camp, and out of them, more than 40,000 prisoners died. You can just imagine the number of the people died there in this concentration camp. And the literate people, the scientists, the doctors, they conducted clinical research on those subjects, on those unfortunate war prisoners of Hitler, from which science got benefited in the long run. What is the history in India? India started its first clinical trial report. So far we have the report. It was in 1945, where some plasma therapy was tried in the cholera patients suffering from dehydration. That time cholera was a big deal in India. People used to die due to diarrhea. Lot of people used to die due to cholera. Okay? And the first controlled clinical trial, earliest controlled clinical trial, it was in 1946 in India for testing a new treatment for malaria. But after that, there was a paradigm shift in the research. So it was 1960s onwards when there was a shift towards non-communicable diseases. There was an epidemiological transition in India. So people from different demographic background, they shifted, they migrated, there were some changes. So disease patterns started evolving towards the other side. কেউ বলতে পারবে when India was যখন ভারত স্বাধীনতা পায়, what was the life expectancy of average Indians?
55.
কত ছিল? 1947 এ ভারত স্বাধীনতা পায়। What was the life expectancy that time? আপনি অনেকটা বাড়িয়ে দিয়েছেন। It was 37 years. It was 37 years. যারা মারা যেত এইখানে যখন আমরা এভারেজ ফিগার নিই তখন সেখানে ইনফ্যান্ট মর্টালিটি নাম্বারটাও তো যোগ হয়ে যাচ্ছে। ছোট বয়সে বাচ্চা যারা মারা যাচ্ছে, 5 বছরের নিচের বাচ্চা মারা যাচ্ছে, সবকিছু মিলে একটা এভারেজ আছে। So it was 37 years. আজকে কত? 65. It is 71 years for the females, and for the males it is 60. 55 years is average life expectancy for the doctors in India. So in general population হচ্ছে প্রায় 70 বছরের কাছাকাছি। তাহলে এই যে চেঞ্জটা, this change was due to lot of changes in the economy, in the science, in the disease pattern, and lot of prevention in the preventive aspects of the disease. Like যেগুলো communicable disease ছিল, diarrheal disease ছিল, সেখানে death drastically reduced হলো। বাকি প্রচুর জিনিস আমরা বাচ্চাদেরকে ছোট বয়সে ভ্যাকসিন হিসেবে দিয়ে দিচ্ছি, মরছে কিসে? নন কমিউনিকেবল ডিজিজ কাউন্টারপার্টটা আস্তে আস্তে বেড়ে যাচ্ছে। তাহলে হাইপারটেনশনের কমপ্লিকেশন, ডায়াবেটিসের কমপ্লিকেশন, ক্যান্সারের কমপ্লিকেশন, এইসব জিনিসের লোকের মৃত্যু হার আস্তে আস্তে বেড়ে যাচ্ছে। তাহলে এই যে একটা চেঞ্জ, এই চেঞ্জটা প্রথম এসেছিল 1960s এর আশেপাশে, বোঝা যায় যখন ক্লিনিক্যাল ট্রায়ালস they were shifted towards the non-communicable epidemiological transition in India. Okay? So coming to 2004, global clinical research industry focused towards India, and India suddenly became a target area for clinical research. Suddenly, there were some changes in the policy. Patent law strengthened kora holo. The government allowed phase 2 and phase 3 studies in India. তার আগে সেটা নিয়েও একটা কনফিউশন ছিল। So the policy modification in India attracted international clinical research organizations and the contract research organizations. মানে আমরা একটু আগে জানলাম যেরকম একজন স্যার বলছিলেন যে অ্যাস্ট্রাজেনেকার সায়েন্টিস্ট যিনি কোভিড ভ্যাকসিনটা আবিষ্কার করেছিলেন, তার ইজ এ company, jara pharma manufacturer. Many times it happens that the pharma manufacturers, they cannot continue with the whole responsibility of the drug development. So drug development is a huge task. They hand over some of their tasks to the third party research organizations. These organizations are called CRO or contract research organizations. So there are multiple CROs all over the world who deal with the clinical research. So they looked at India and they started taking the advantage of India in the form of large pool of patients, প্রচুর পেশেন্ট, আমাদের দেশে সংখ্যার অভাব নেই, রোগেরও অভাব নেই, কস্ট এফেক্টিভ হিউম্যান রিসোর্স, কম পয়সায় প্রচুর স্কিল লোককে পাওয়া যাবে, তাই তো? মাইনে দেওয়ার সময় এমপ্লয়াররা পুয়ার হয়ে যায়। লো রিক্রুটমেন্ট কস্ট, লো রিক্রুটমেন্ট কস্টটা আমি পরে একবার ডিসকাস করব যে ইউএস এর সাথে রিক্রুটমেন্ট কস্ট, রিক্রুটমেন্ট মানে একটা ট্রায়ালে একজন পার্টিসিপেন্টকে যে রিক্রুট করা হয় তার একটা খরচ থাকে, সেই খরচটা প্রায় 10-fold কম ইন্ডিয়া। $1,000 to $2,000 ছিল এস্টিমেটেড কস্ট ইন ইন্ডিয়া, যেটা ইউএসএ তে একটা পেশেন্টকে রিক্রুট করলে সেই খরচটা দাঁড়ায় অ্যারাউন্ড $20,000। So it is more than 10 times of it. Okay, so low recruitment cost, and যেখানে এত large pool of patient থাকবে, so there will be timely completion of the clinical trials in India. This is a big challenge for the CROs and the pharma manufacturers because the drug development, it takes around 12 to 15 years. So what is the period for a drug? Anybody?
17 years.
It is 20 years. তো 20 ইয়ার্স এর মধ্যে যদি 15 বছর ওষুধটাকে তৈরি করে মার্কেটে আনতেই লেগে যায়, তাহলে বাজারে সে ওইটাকে বেচে খাবে ক বছর? 5 বছর। তাহলে তার মধ্যে তার ইনভেস্টমেন্ট করবে তো। সো দিস ইজ এ বিগ চ্যালেঞ্জ। তাহলে সেখানে যদি 2 বছর ড্রাগ ডেভেলপমেন্টের টাইমটাকে কমিয়ে ফেলা যায়, তাহলে আলটিমেটলি সেই ফার্মা কোম্পানি কুড বি বেনিফিটেড। সো দি CROs, they get challenged in patient recruitment all over the world. India didn't have that challenge because we have a lot of patients. মানুষ চারদিকে গিজগিজ করছে, শুনে অসুবিধা কিছু নেই। So timely completion of the clinical trials in India and lower rate of compensation from the injuries during clinical trials. সেটা মানে কি? Clinical trial চলাকালীন if somebody gets inadvertently harmed or died, there is a provision of compensation. So the compensation in India that time was very low, and many times it was not given. Yeah, they won't. So due to all these reasons, the pharma market, clinical research market, it started swelling. Swelling at kilogram range chilo. So the lower drug development cost. So this resulted this type of graph in the increase in clinical business, clinical trial business in India. So this is 2005 and last figure is 2011. You can see that there is a jump in the number of clinical trials. So was it good or bad? কি ভালো না খারাপ? Pharma industry, you are all pharmacy students, so you are intricately linked with drug development. তোমরা এটাকে ভালো বলবে না খারাপ বলবে? যদি এরকম মেডিকেল রিসার্চ ইন্ডাস্ট্রি বাড়তে থাকে তাহলে তোমাদের এমপ্লয়মেন্ট বাড়বে। তাহলে সেই দিক দিয়ে যদি ভাবো ইট ইজ গুড, প্রচুর লোকের এমপ্লয়মেন্ট জেনারেট হলো, ইন্ডিয়াতে ফরেন রেভিনিউ আসা শুরু হলো, অনেক দেশ থেকে লোকজন আসা শুরু করলো। তাহলে প্রবলেম কি? হঠাৎ করে দেখা গেল there is a big problem after this 2011 and suddenly this number gone down. কি হলো? India hosts nearly a fifth of all global clinical trials, and this is a massive growth undoubtedly, but at the same time you can see this report in 2011. Clinical trials claimed 25 lives in 2010. Only 5 paid compensation. This type of disturbing news is started coming in the newspapers. Clinical trial death was. It was published in 2012 in the newspaper Mint, the dark underbelly of Indian clinical trial business. কি হলো? Bhopal gas tragedy. তোমরা কেউ Bhopal gas tragedy নাম শুনেছো? So there was a factory of Union Carbide from where some gas leaked and many people died. After that, ওইখানে একটা হসপিটাল তৈরি হয়, একটা ICMR এর রিসার্চ সেন্টার তৈরি হয়। সেই হসপিটালে the survivors of the gas tragedy, they were treated like guinea pigs. Without their consent, they were taken to the clinical trials. And this is the picture of the protest in front of the Bhopal Memorial Hospital. So this newspaper, they reported that in 2005, India introduced the patent protection law, became a global hub in clinical trial, and bringing down the research and development costs nearly 60% in phase 2 and phase 3 trials. সারা পৃথিবীতে বাইরের দেশে যে কোনো জায়গাতে ফেজ 2 ফেজ 3 করতে যা খরচ পড়বে তার থেকে 60% কম কস্টে ইন্ডিয়াতে করা যাবে। তাহলে লোকে আসবে না, সস্তা পেলে বাপ বাপ করে চলে আসবে। তাই হলো Indian test subject cost between $1,500 to $2,000. In US, it would cost around $20,000. তাহলে তো cost reduction হবেই। But তার সঙ্গে কি হচ্ছে? Lot of unethically conducted trials were mushrooming in India. 2012, India Today. Illegal drug trials have claimed 32 lives and mined 49 in Madhya Pradesh. It was published in the journal Nature. This article 2012. India shakes up rules on clinical trials. Ki hoyechilo? That time the news is started coming so frequently that the government, union government was under pressure. The health minister has to give a statement in front of the whole parliament. That time, the health minister of Union of India, Mr. Ghulam Nabi Azad, he reported that 668 people died during clinical trials in India in 2010. এক বছরে 668 জন মানুষ মারা গেছিল due to clinical trial. And this figure is probably a smaller figure than the actual. Because most of the time these are not reported properly. This was published in BMJ in 2013. 2012 পরে 2013. Indian Supreme Court tells the government to act on illegal clinical trials. এইবার সবকিছু নড়ে চড়ে বসা শুরু হলো যে তুমি গভর্নমেন্ট কেন চুপ করে রয়েছো? You have to do something. But in spite of that, some of the remedial measures has been taken. Still we get this type of reports in 2017 or even in 2018, where it was shown that illegal drug trial in Rajasthan Why are poor treated as guinea pigs? Ask the rights group. So with this background, we can well understand that there was no end of bad science. So good science, bad science, doing things in a wrong way. So these were harming the people. Okay. So this was published in the Perspectives Research. A large proportion of Sikh Indians, why Indians were being treated like a guinea pig. So Malla and Chawla, they mentioned a large population of Sikh Indian are poor, illiterate, and with no access to good health care. They are highly vulnerable to inducement and exploitations in clinical trial. যে লোকটা খেতে পাচ্ছে না, তার রোগ হয়েছে, তাকে যখন আমরা গিয়ে বলছি আপনাকে নিয়ে যাব, আপনাকে যাওয়া আসার খরচ দেব, আপনাকে তার সঙ্গে আরো 50 টাকা হাতেও দেব, দুবেলা খাবেন, আপনার ট্রিটমেন্ট আমরা করে দেব, সেই ট্রিটমেন্টের বেনিফিট হবে কি হবে না তুমি জানো না। It is a clinical trial. Trial is research, so there is some uncertainty. It may happen, it may not happen, but they are duped. They get this inducement. They have আমি যাই গেলে আমার কিছু বেনিফিট যদি হয়, and they started falling prey of the clinical trial industry. তোমাদের মনে হতে পারে আপনি যে একজন ক্লিনিক্যাল রিসার্চার, আপনি এরকম নিজেদের সম্বন্ধে এত গালাগালি কেন করছেন? আমি গালাগালি করছি না, I am just taking some facts out. There is nothing like absolute black and absolute white. There are some gray areas in between, and we have to look at those gray areas. Okay? So clinical trials, is it a need or a luxury for countries like India? এই কোশ্চেনটা তাহলে চলে আসে যে বাবা তুমি তো কি করতে এলে আমার দেশে, ট্রায়াল করার নাম করে এত লোককে মেরে দিচ্ছ, এত সব উল্টোপাল্টা কাজ করে বেড়াচ্ছ, তাহলে এটা করার দরকার মনে হতে পারে। তাহলে মনে হলেই হলো, ক্লিনিক্যাল ট্রায়ালটা তাহলে কোথায় হবে? Incidentally, more than 80% clinical trials which are registered or listed in the website clinicaltrial.gov. So US এবং internationally যত clinical trial হয় সেগুলোকে এইখানে রেজিস্টার করতে হয়। দেখা যায় more than 80% trials are conducted in the developed world. Developed world মানে USA, UK, European countries, এরা হচ্ছে developed world. কিন্তু পৃথিবীর ম্যাক্সিমাম পপুলেশন থাকে কোথায়? ডেভেলপড ওয়ার্ল্ডে না ডেভেলপিং ওয়ার্ল্ডে? ডেভেলপিং ওয়ার্ল্ডে। তাহলে পৃথিবীর ম্যাক্সিমাম পপুলেশন যেখানে থাকে ডেভেলপিং ওয়ার্ল্ডে, অবভিয়াসলি ডিজিজও সেখানে বেশি থাকবে। ঠিক আছে, তাহলে ডিজিজ যদি সেখানে বেশি থাকে তাহলে ট্রায়ালটা কোথায় হবে? আমার বাড়িতে যদি খাবার না থাকে, পাশের বাড়িতে খাবার থাকে, তাহলে কি আমার পেট ভরবে? ভরবে না। তাহলে আমার দেশে যদি পপুলেশন ডিজিজ থাকে, তাদেরকে সারানোর দায়িত্ব কার? আমার। আমেরিকা, ইউএস, ইউকে, ওয়েস্টার্ন কন্টিনেন্ট আগে টিবি নিয়ে পাত্তা দিত না। কেন? থার্ড ওয়ার্ল্ডের রোগ। আজকে বাপ বাপ করে পাত্তা দিচ্ছে কেন? কারণ এইচআইভির হাত ধরে ওদের দেশেও টিবি ঢুকেছে। and they got a naive population, তাজা তাজা প্রাণ পাচ্ছে। আমার দেশের গুলো একটু তবু ভ্যাকসিন ট্যাক্সিন পেয়ে আমাদের নিজেদের কিছু ন্যাচারাল রেজিস্ট্যান্স থাকে, ওদের ইনেট ইমিউনিটি আরো কম, যেখানেই ধরছে একদম অবস্থা খারাপ। তার ফল কি হলো? এত বছর ধরে টিবি ট্রিটমেন্ট চলছে, there was no change in the regimen. After 40 years a new antibiotic and it was marketed. The name of the antibiotic is bedaquiline, which was introduced for multi-drug resistant tuberculosis with a restricted permission. বাজারে পাওয়া যাবে ওটা একমাত্র কিছু কিছু মেডিকেল কলেজ এবং কিছু কিছু টিবি ট্রিটমেন্ট সেন্টারেই পাওয়া যাবে। So came with this bedaquiline and then another drug named delamanid. So these two drugs came for treatment of multi-drug resistant tuberculosis. কারা তৈরি করছে? জনসন এন্ড জনসন। কেন তৈরি করছে? বুঝতে পারছি এখানে ব্যবসা আছে। ফার্মা কোম্পানি এমনি এমনি পয়সা ঢালবে, ঠিক আছে? So developing countries, they constitute 90% of the disease burden of the world. So obviously these countries are underrepresented in research due to lack of commercial viability and research capacity. তো কিছুদিন আমার খুব স্বাদ হয়েছিল একটু ম্যানেজমেন্ট করব, কি আছে ওটার মধ্যে যে এরা এত পড়াশোনা করেছে, লোকজন চারদিকে এত টাকা মাইনের চাকরিও পায়। তো এমডি করে আসার পরে কিছুদিন মনে হলো একটুখানি সিকিম মণিপালের একটা কোর্সে ভর্তি হলাম। তো ওইখানে কোন সাবজেক্টে পড়েছিলাম ভুলে গেছি, আমি ফাইনালি পরীক্ষাটা দিইনি, কারণ আমি জাস্ট জানার জন্য সাবজেক্টটার ভেতরে ঢুকেছিলাম। বেশ কটা এমনি সেমিস্টার দিয়েছিলাম, সেগুলোতে খুব ভালো নাম্বারও পেয়েছিলাম। তো একটা সেরকম গল্প পেয়েছিলাম যে দুজন সেলার একটা জুতোর কোম্পানি, they were sent to Nigeria or any some other African country, নাম নেওয়া উচিত না এভাবে, এটা জাস্ট বলার জন্যই বলছি যে দুজনকে পাঠিয়েছে দেখে এসো এখানে জুতোর বিক্রির মার্কেট কেমন আছে। প্রথম সেলার, প্রথম রিপ্রেজেন্টেটিভ ফিরে এলো, দুজনেই ফিরে এলো ওখানে সার্ভে টার্ভে করে এসে তারপরে তার কোম্পানির বস জিজ্ঞেস করছে যে কি খবর, কিরকম দেখলে বিজনেস অপরচুনিটি। তো প্রথম জন বলল যে কোনো অপরচুনিটি নেই। কেন? লোকে জুতো পরতেই জানে না, খালি পায়ে ঘোরে, সে যা দেখেছে সেটাই বলে এসছে। সেকেন্ড লোকটাকে ডাকলেন বস, কি দেখলে বলো। স্যার এক্সিলেন্ট মার্কেট। কি করে? আমি তো শুনলাম যে ওখানে লোকে জুতো পরতেই জানে না। স্যার সেই জন্যই তো কোনো কম্পিটিটর নেই, ওদেরকে যদি একবার জুতো পরা শিখিয়ে দিই পুরো মার্কেটটাই আমাদের হাতে। সো এটা হচ্ছে পারসেপশনের ডিফারেন্স। তাহলে আমার দেশে 90% ডিজিজ বার্ডেন নিয়ে আমরা বসে থাকবো আর এক্সপেক্ট করবো যে অন্য দেশের লোক এসে আমার এখানে নতুন ড্রাগ দিয়ে যাবে। ইট ইজ নট পসিবল। আমাকে আমার নিজের রাস্তা বের করতে হবে। So these countries are underrepresented in research. There is no doubt that we had lower infrastructure for research. We had lower manpower capacity for clinical trials. The doctors, the medical scientists, they were mostly utilized for service. Primary health center এ আমাকে যাওয়া শেখানো হয়েছে। সবাই এক্সপেক্ট করতো যে আমি অনেক টাকা রোজগার করে আনবো, তার বাইরে কেউ কখনো ভাবতে চায়নি। কিন্তু আজকে বোঝা যাচ্ছে যে এটাও দরকার। There is no one to lead India, কারণ আমার দেশের স্বাস্থ্য আমার রেসপন্সিবিলিটি। অন্য দেশ তখনই আসবে যখন সেখানে বিজনেস অপরচুনিটি পাবে, না হলে ঢুকবেন। ঠিক আছে? তাহলে আমরা বুঝতে পারছি যে ক্লিনিক্যাল ট্রায়াল ইজ নট এ লাক্সারি ইন কান্ট্রিজ লাইক ইন্ডিয়া, ইট ইজ এ নেসেসিটি, and to comply with this necessity we need a formal drug development thing. তাহলে ড্রাগ ডেভেলপমেন্ট কি করে হয়? এনি আইডিয়া? ড্রাগ ডেভেলপমেন্টের সম্বন্ধে কি কি ফেজ থাকে কোনো আইডিয়া আছে তোমাদের? কেউ কিছু বলতে পারবে? বললেই পরে একটা ক্যাডবেরি পাবে। So drug development is typically divided into preclinical phase and clinical phase. So one part is preclinical development, যেটা মানুষের শরীরে দেওয়ার আগের পার্ট। ইন ভিট্রো স্টাডিজ হয়, অ্যানিমাল স্টাডিজ হয়, সেখান থেকে অ্যানিমালের উপর টক্সিসিটি, এফিকেসি, এই যে ম্যাডাম যে সুন্দর এক্সাম্পল গুলো দিলেন, অ্যানিমালের মধ্যে ডিজিজ ক্রিয়েট করে তারপরে তার মধ্যে এফিকেসি দেখা হয়। উনি লাস্টে যে এক্সাম্পলটা দিলেন যে চোখে কন্ট্যাক্ট লেন্সটা, so this was example of a disease model with the animals. তাহলে অ্যানিমালের মধ্যে এফিকেসি দেখা হয়, সিমিলার ওয়েতে অ্যানিমালের মধ্যে টক্সিসিটিও দেখা হয়। Once these tests give some positive report, now the company they submit these reports to the regulator. ইন্ডিয়াতে রেগুলেটরের নাম কি? CDSCO. তো অনেকে ইউএসএফডি এর নাম জানো? ইউএসএফডিএ হচ্ছে আমেরিকান রেগুলেটর। ইএমএ ইউরোপিয়ান মেডিকেল এজেন্সি, সেটা হচ্ছে ইউরোপের জন্য, পুরো ইউরোপকে তারা রেগুলেট করে। তাহলে এর কাছে সাবমিট করে কি জন্য? না প্লিজ অ্যালাউ আস ফর হিউম্যান ট্রায়াল। ঠিক আছে? তাহলে preclinical stage, it is followed by clinical trials. So clinical trial এর মধ্যে এখানে phase 1 followed by phase 2 and phase 3. Phase 1 is called first in human trial. So as a pharmacy expert, you must know all these things. কি করা হয়? Phase 1 it is usually done in the healthy volunteers, excepting cancer and HIV and rare diseases. বাকি সব জায়গাতে কি করা হয়? হেলদি ভলান্টিয়ারদের মধ্যে অ্যাপ্লাই করা হয়। তাদের মধ্যে তার ড্রাগের ফার্মাকোকাইনেটিক ডাইনামিক ডেটা নেওয়া হয়, সেফটি দেখা হয়। Once it produces good result phase 1, phase 1 খুব লিমিটেড জায়গাতে হওয়া সম্ভব। In India we have very limited centers for phase 1. So once it clears the phase 1, the drug enter the phase 2. আবার তার জন্য পারমিশন নিতে হবে। Phase 2 তে কি হবে? It is first time in the disease population. আগের বারটা ছিল healthy population, now it is on the disease population, but on a limited number of patients. কত লিমিটেড? 100-200 এই লেভেল। ঠিক আছে, ম্যাক্সিমাম 500 পর্যন্ত যেতে পারে। তো এইখানে ফেজ 2 তে আমরা কি করি? আমরা চেষ্টা করি ডিজিজ পপুলেশনের মধ্যে সেফটি এন্ড এফিকাসি দেখা and to find out the dose. কি এক্সাক্ট ডোজ রেঞ্জে এটা ভালো কাজ করছে সেটা। কারণ তার আগে আমরা যেটা করেছিলাম অ্যানিমেলের উপর করেছিলাম, সেখান থেকে আমরা এক্সট্রাপোলেট করেছিলাম ডোজটা হিউম্যান ডোজ। Do you have any idea how many of the animal studies become successful in the clinical development? Animal study is mandatory. আবার বলছি চকলেট দেবো। Animal study is mandatory. কত পার্সেন্ট স্টাডি ফাইনালি সেখান থেকে পজিটিভ রেজাল্ট দেয়? Only 10 to 15%. Why? Because animals are animals, human are human. Animal সিস্টেম আলাদা সিস্টেম দিয়ে তৈরি, আমাদের সিস্টেম একটু আলাদা। আমরা যতই বলি যে ওটা ইন ভিভো, এটাও ইন ভিভো, কিন্তু সেটা ম্যাচ করে না। কিন্তু স্টিল ইউ নিড টু গো থ্রু দ্যাট টক্সিসিটি স্টাডি। ওকে, তো তারপরে ফেজ 2 তে যদি সাকসেসফুল থাকে on the disease population, then the study enters in the phase 3. You need another permission. Phase 3 are usually multi-center. Multiple center all over the country, different area থেকে representation নেওয়া হয়, নিয়ে সেখানে স্টাডি গুলো করা। So participation may range from 100 to 1000. So 500 to 5000 it is the usual range. For vaccine clinical trials, it may go up to 30,000, 40,000 also. So ICMR was one part of the Covaxin clinical trial. So Covaxin was for the COVID vaccine. So সেখানে total subject ছিল approximately 30,000. So it was a seamless design. Phase 2 study তে যারা include হয়েছিল সেখান থেকেই তাদেরকে phase 3 তে continue করা হয়. So after this phase 3, if it gets successful, এইবার তোমার বাজার। তুমি এর মধ্যে অলরেডি কয়েকশো মিলিয়ন ডলার খরচ করে ফেলেছে। কেন? কারণ এই পার্টটা হয়তো দেখা যাবে 10 বছর 12 বছর কেটে গেছে। Now if you have this phase 3 result in hand, তুমি এবারে গিয়ে সিডিএসসিও কে দেখাবে, এই দেখুন রাজার ঘরে যে ধন আছে, টুনির ঘরে সে ধন আছে। কি আছে? সাকসেস ডেটা। ওকে, সাকসেস ডেটা নিয়ে so you are getting the marketing approval. কি করতে পারবে? কেমিস্ট শপে গিয়ে বিক্রি করতে পারবে। তো আলটিমেট টার্গেট কি? এরকম ইন্ডিয়ার মতো দেশে যেখানে কি বিল করছে লোক, টার্গেট তো সেই মার্কেটিং অ্যাপ্রুভাল। সেখানে গেলে তবেই তো আমি বিজনেসটা পাবো, যা খরচ করেছি সুযোগ পাবো। তাহলে কেমিস্টের কাছে আমি পাঠালাম অ্যাপ্রুভাল। খেলা শেষ? খেলা শেষ নয়। কি হবে এরপরে? পোস্ট মার্কেটিং সার্ভিলেন্স, যেটাকে বলা হয় phase 4. ঠিক আছে, তাহলে এর পরের ফেজে হলো phase 4. So post marketing studies will be conducted. তাহলে these are the drug development and phases of clinical trial. This is very important for the pharmacy students because you have to know, you have to learn the stages of clinical trial, and to get a good job in your future, this is a fantastic line where you can enter this clinical trial discipline. Okay. So what are the platforms required for clinical research? So platform, আমরা প্ল্যাটফর্ম মনে করলে এরকম ভালো ভালো সুন্দর সুন্দর প্ল্যাটফর্মের কথা মনে করতে পারি, অথবা শিয়ালদা সাউথ লাইনের প্ল্যাটফর্মরাও আছে, এখানে প্রচুর দোকান, হাঁটা চলার জায়গা নেই, সেসব জায়গাও থাকে। তো যেটাই হোক, সুন্দর প্ল্যাটফর্ম হোক আর বাজে প্ল্যাটফর্ম হোক, প্ল্যাটফর্মের গোটা গোটা জিনিস আমাদের দরকার। সেই জিনিসগুলো কি? তো ফার্স্ট থিং ইজ রেগুলেটরি এনভায়রনমেন্ট। এই যে ঘরটার মধ্যে তোমরা সবাই বসে রয়েছে, সুন্দর একটা এসি চলছে, সবাই চুপচাপ বসে রয়েছে, আমি অল্প বিস্তর বোর করছি, বাকি খুব একটা চ্যালেঞ্জ তোমার কাছে নেই। এই ঘরটার মধ্যে যদি এক্ষুনি এসি ফেলিওর হয়ে যায় আর চারদিকের দরজাগুলো বন্ধ করে দেওয়া হয়, বা তোমাদের অথরিটি বললো যে এখানে এসিটা বন্ধ করতে হবে, তারপরে কি দাঁড়াবে অবস্থাটা? এনভায়রনমেন্ট একটা ক্যাওস তৈরি করে দেবে, তাই তো? তাহলে এনভায়রনমেন্টটা দরকার ভালো কিছু পেতে গেলে। ক্লিনিক্যাল রিসার্চের জন্য সেই এনভায়রনমেন্টটা হচ্ছে রেগুলেটরি এনভায়রনমেন্ট। তার মানে গভর্নমেন্ট অফ ইন্ডিয়া, CSCO এরা এমন কিছু এনভায়রনমেন্ট তৈরি করে দেবে that can produce a good situation for the pharma companies to conduct a clinical trial, but it still protects the subjects from the trial related atrocities. Adequate protection তাদের জন্য, ঠিক আছে? আর কি থাকবে? এথিক্স। ওই যে সকালবেলাতে আমরা শুরু করলাম লেকচারটা, আমার লেকচারটাই সকালবেলাই বলছি, অনেকক্ষণ আগে শুরু করেছিলাম। তো সেখানে আমরা সেই ডাকাওয়ের কনসেন্ট্রেশন ক্যাম্পের কথা বললাম, যেখানে হাইপোথেটিক্যাল এক্সপেরিমেন্ট করা হতো, মানুষকে না খাইয়ে দেখা হতো কি করে ওর বডি মাসল গুলো ডিগ্রেড করতে থাকে এবং ফাইনালি লোকটা মারা যায়। ঘুমোতে না দিয়ে এক্সপেরিমেন্ট করা হয়েছে। তাহলে এই যে ভয়ানক ভয়ানক এক্সপেরিমেন্ট গুলো করা হয়েছিল, তো সেটা কি ছিল? এথিক্স ভায়োলেশন। There was no scope of ethics. আজকে কি করতে হয়? আজকে একটা ট্রায়াল করতে গেলে ফার্স্ট হলমার্ক অফ এনি ethical principle starts with autonomy. Autonomy মানে আমি ট্রায়ালে পার্টিসিপেট করব কি করব না, ভেরি মার্সি। কনসেন্ট, আমার কাছ থেকে কনসেন্ট নেওয়া হবে প্রথমে, ঠিক আছে? অটোনমি, যিনি ট্রায়ালটা করবেন, he will look for the benefit of the participant, যেটাকে বলা হয় বেনিফিসেন্স। Then comes non-maleficence, যেখানে বেনিফিট করতে পারছি না, অন্তত ক্ষতি করার চেষ্টা করব। And finally, justice. Justice কি? ডাকাওয়ের কনসেন্ট্রেশন ক্যাম্পে যে ট্রায়াল গুলো করা হয়েছিল, সেইগুলো দিয়ে কি ওইখানকার মানুষদের কোনো বেনিফিট হয়েছিল? সেই কনসেন্ট্রেশন ক্যাম্পের লোকগুলো কোনো বেনিফিট তাদের কোনো ভাবা হয়। তাহলে যখন আমরা পার্সপেক্টিভ ধরে ভাববো, দি জাস্টিস প্রিন্সিপালটা হচ্ছে যে যে কোনো জায়গাতে কোনো পপুলেশনকে আমরা অন্য পপুলেশনের জন্য ইউজ করব না। So that is justice. Okay. So ethics, then establishment, that is the trial sites, human resource, sponsor, funding, and data security and privacy. So regulatory environment, সেটা গভর্নমেন্ট প্রোভাইড করে, আমরা অলরেডি বললাম। স্পন্সর, ট্রায়াল সাইট, হিউম্যান রিসোর্স, আদার সাপোর্টস, ডেটা সিকিউরিটি এন্ড এথিক্স। তার মধ্যে আমরা শুরু করি স্পন্সর। শুড হ্যাভ অ্যাডিকুয়েট সোর্স অফ ফান্ডিং, should have the adequate supply of the medicine. Medicine মানে new chemical entity অথবা investigational new drug. New chemical entity when it is in the preclinical stage. Once it enters trial, it becomes investigational new drug. Okay? তাহলে সেটার সাপ্লাই দিতে হবে। Arrange for insurance or compensation. টাকার সাপ্লাই, ইন্স্যুরেন্স বা কম্পেনসেশনের জন্য প্রোভাইড করতে হবে। Trial site, there should be adequate space, adequate number of participants, adequate medical facility, emergency service, and finally willingness of the administration. সেই administration যদি না চায়, কোনোদিন সেখানে ভালোভাবে ট্রায়াল করা যাবে। বসার জায়গাটাই দিল এমন যেখানে কিচিরমিচির সারাক্ষণ হচ্ছে, তো কনসেন্ট নেবে কি? পেশেন্ট তো বাপরে মারে করে এমনি পালিয়ে যাবে, ঠিক আছে? So human resource, trained PI or co-PI. PI মানে principal investigator, ঠিক আছে? Research associate and other support staff. The properly adequate number of support staff. Ethics. So there, ethics এর ব্যাপার বলতে গেলে there should be a proper ethical guidelines which is pertinent to that country. Some of the things are peculiar to certain countries which are not there in other countries. আমার দেশের যে পার্সপেক্টিভ সেটা অন্য দেশের সাথে ডিফারেন্ট হতে পারে, সেই অনুযায়ী সোশ্যাল সিস্টেমের উপর ডিপেন্ড করে এথিক্স এর প্রিন্সিপাল গুলো ভ্যারি করতে পারে। ঠিক আছে, রেজিস্টার্ড এথিক্স কমিটি আগে একটা সময় ছিল যে কোনো লোক যে কোনো দল তারা একটা এথিক্স কমিটি খুলে বসে থাকতো। তো গভর্নমেন্ট এখন রেগুলেশন আনলো যে যদি ক্লিনিক্যাল ট্রায়াল করতে হয় ওই রকম ইন্ডিপেন্ডেন্ট এথিক্স কমিটিকে দিয়ে করানো যাবে না। কেন? কারণ সেই এথিক্স কমিটি গুলো যখনই প্রয়োজন তখন আছে, যখন প্রয়োজন নেই তখন সেগুলো আনট্রেসেবল। 10 জন লোক আমরা একসাথে ছিলাম, আমরা একটা এথিক্স কমিটি ফর্ম করলাম, উনি একটা ক্লিনিক্যাল ট্রায়াল করছেন, ওনার ওটাকে দিয়ে আমরা অ্যাপ্রুভ করে দিলাম, যাওয়ার সময় পকেটে কিছু পয়সা করে নিলাম। তো সেটা কি দিয়ে রিপ্লেস হলো? বললো নো, for clinical trials you need institutional ethics committee which is attached to some institute. So medical colleges they have their human ethics committee, ICMR they have their own ethics committee. ঠিক আছে, তাহলে ethics guidelines শুধু না, তারপরে ethics committee। গভর্নমেন্ট এখানেই থামলো না, বললো তারপরে নেক্সট স্টেপ হচ্ছে you have to register this ethics committee, কারণ আমরা জানতেই পারছি না দেশে কতগুলো ethics committee আছে, 100টা আছে না 1000টা আছে। ঠিক আছে, মিটিং এট রেগুলার ইন্টারভালস, এথিক্স কমিটি থাকলেও কোনো মিটিং হয় না, ট্রায়াল কেউ ফলো করে না, সেটাও চলবে না, তাহলে সেটার জন্য ব্যবস্থা করতে হবে। and supports ethical conduct of research, যে ethics committee is not a barrier to your Nobel Prize, যেটা অনেকে ভাবে। বিভিন্ন জায়গাতে এথিক্স কমিটিতে যারা কাজ করার অভিজ্ঞতা আছে আমাদের অনেক কলিগরাই ভাবে তার সাথে নোবেল প্রাইজের মাঝখানে ব্যারিয়ার হচ্ছে এথিক্স কমিটি, না হলে এই এথিক্স কমিটিতে এটা আটকানো পেয়ে যাচ্ছিলাম, কিন্তু ব্যাপারটা তা নয়। এথিক্যাল কন্ডাক্ট অফ রিসার্চ, সো দেয়ার ইজ নো রাইট ওয়ে অফ ডুইং রং থিংস, তাহলে এথিক্যাল কন্ডাক্ট অফ রিসার্চ প্রমোট করে এরকম এথিক্স কমিটি, এখানে সাবজেক্টের বেনিফিটটাকেও দেখা হয়। ডেটা ম্যানেজার্স CDM team maintains privacy and no scope of tampering of the data or manipulation of the data. Okay? And finally, other supports like trial registration or listing, laboratory support, internet and connectivity. তাহলে এই একটা হিউজ জিনিস চারপাশে খুব সংক্ষিপ্ত করে আমি প্ল্যাটফর্মটাকে সাজানোর চেষ্টা করলাম। So with this background, এবার তোমরাই বলো ইন্ডিয়াতে কি কি আছে এই প্ল্যাটফর্মের মধ্যে, একটু দেখে নেওয়া যাক। ঠিক আছে, so platform in the Indian scenario is largely contributed by Department of Health Research ICMR in one side and CDSCO, New Drugs and Clinical Trial Rules, Sugam Portal, Trial Registry of India, this type of services in Indian. So first is strengthening of the ethics oversight. আমরা এক এক করে দেখছি যে আমাদের ইন্ডিয়াতে কি কি জিনিস আমরা এখন পর্যন্ত ভালোভাবে। So national ethical guidelines is published by ICMR, Indian Council of Medical Research, for biomedical research in the human subjects. This guideline came in force in 2017. এর আগে 2005 এর একটা গাইডলাইন ছিল যেটাকে রিভাইজ করে বানানো হয়। Till now this is one of the best ethics guidelines all over the world. India can be boast of these guidelines because they work extensively and collected information from all over the world, from all the guidelines, and they accumulated all those things in this Indian guidelines. So ICMR biomedical guidelines, they support ethical conduct of research. They mentions mandates about training, about the rules and regulations of the ethics committee members. অনেক জায়গাতে ethics committee member এমন লোক আছেন যিনি খুব হেভি ওয়েট, কিন্তু তিনি রুলস রেগুলেশনস নিজেই জানেন না, তাহলে সেখানে কি করে এথিক্যাল কন্ডাক্ট হবে? তাহলে সেখানে বলা হচ্ছে ইট ইজ ম্যান্ডেটরি টু কন্ডাক্ট ট্রেনিং থ্রু আউট দ্য ইয়ার, বছরে অন্তত 2-3টে ট্রেনিং, সেটা তোমাকে আগে থেকে ইনফর্ম করতে হবে আমি বছরে 2টো করে মিনিমাম ট্রেনিং করাবো, যাতে আমার মেম্বাররা যাতে জানতে পারে যে কি কি চেঞ্জেস আসছে রুলস রেগুলেশনস, এন্ড মিটিং এট রেগুলার ইন্টারভালস। তো এটা গেল হচ্ছে আমাদের স্ট্রেংথেনিং অফ দি এথিক্স প্ল্যাটফর্ম। তাহলে এথিক্স প্ল্যাটফর্ম হলো এইখানে efforts must be made to ensure that individuals or communities invited in research are selected in such a way that benefits and burdens of research are equally distributed. সেই ঢাকা কনসেন্ট্রেশন ক্যাম্প সেই তুমি একটা ট্রাইবাল পপুলেশনের উপরে নিয়ে গিয়ে এক্সপেরিমেন্ট করে দিলে বেনিফিট কে পাবে বড় বড় যারা ফিনান্সিয়ালি রিচ লোকজন সেটা যাতে না হয় রিস্ক বেনিফিট এবং বার্ডেন সবগুলো যাতে শেয়ার সবাই মিলে যাতে একসাথে শেয়ার করে and vulnerable individuals and groups should not be included in the research to solely benefit others who are better well off who are vulnerable population vulnerable মানে কি any idea what is vulnerable আমি এটা খুব সহজ एग्जांपल দিই তুমি স্টুডেন্ট তোমাকে পাস করতে হবে তাই তো আলটিমেট টার্গেট কি পাস করতে হবে সবাই জন্মায় বড় বড় উদ্দেশ্য নিয়ে পরীক্ষার আগের দিন সবারই একটাই উদ্দেশ্য থাকে পাস করব ঠিক আছে তো পরীক্ষার আগে তুমি জানো যে তোমাকে পাস করতে হবে আমি তোমার স্যার আমি এসে বললাম তোদের 30 জনকে পার্টিসিপেট করতে হবে ক্লিনিক্যাল ট্রায়াল সো হু ইজ ভালনারেবল ইউ স্টুডেন্টস আর ভালনারেবল তাহলে অন্য কোন সোসাইটির অন্য কোন স্ট্যাটাকে বেনিফিট করার জন্য এরকম কোন ভালনারেবল গ্রুপকে আমরা স্টাডিতে ইনক্লুড করতে পারি না হু আর দি আদার ভালনারেবল পিপল প্রিজনার্স সাইকিয়াট্রিক পেশেন্টস অ্যাসাইলামে রয়েছে সাইকিয়াট্রিক পেশেন্ট পাগলাগারদে যে পেশেন্টরা রয়েছে ওরা তো নিজেদের ডিসিশন নিজেরা নিতে পারে না তো তাকে যদি আমি একটা অন্য কিছু ড্রাগ ট্রায়ালের মধ্যে পার্ট করে দিই হ্যাঁ এমন হতে পারে সেখানে আমি পাগলামির ওষুধের একটা চিকিৎসা করছি that is a different issue কিন্তু অন্য কিছুর জন্য আমি ইউজ করার আগে সেখানে ভালনারেবল পপুলেশন কিনা এথিক্স কমিটি সেটাকে জাজ করবে ওকে সো দিস ইজ এক্সাম্পল অফ জাস্টিস যে কথাটা আমি আগে বলছিলাম সো জাস্টিস the research should not lead to social racial or ethnic inequalities and plan for direct or indirect benefit sharing if there is a possibility of commercialization যদি possible commercialization থাকে after that research it should be shared among the participants okay regulatory environment there were certain reforms তার মধ্যে আমরা 2005 এর রিফর্মের কথাটা অলরেডি ডিসকাস করেছি 2013 there was further revision of schedule Y and 2019 there was a huge change in the form of NDCT 2019 new drugs and clinical trial rules যেখানে প্রচুর জিনিস আকাশ পাতাল পরিবর্তন করেছে so this was published in the Gazette of India in 19th March 2019 and this is a huge book of 108 pages 13 chapters 107 rules 8 schedules and 27 forms which are all related to clinical research or clinical trials okay so this was in abolition of the schedule Y ছিল drugs and clinical trial rules 1945 এর schedule Y বলে একটা ছিল যে এই শিডিউলটার মধ্যে এই drug development এর part clinical trials and rules এই সমস্ত বলা হতো now this schedule Y will be obsolete after this 2019 NDCT 2019 okay কি বলা হলো this is applicable to all new drugs investigational new drugs clinical trials bioequivalent study bioavailability study and to the ethics committees কি নতুন আছে এটাতে I am skipping for the sake of time so they mentioned that in chapter 3 they mentioned about one ethics committee for clinical trials and in chapter 4 they mentioned another ethics committee for biomedical and health research which are not clinical trials okay? And in chapter 6 they mentions about compensation how to calculate the compensation if there is a serious adverse event suppose একটা লোক ট্রায়ালে পার্টিসিপেট করেছিল এবার বাড়ি থেকে বের হলো ওই ট্রায়ালে পার্টিসিপেট করে ওষুধটা খেয়ে রাস্তায় বেরিয়েছিল লোকটা অ্যাক্সিডেন্ট হয়ে মরে গেল এটা কি সিরিয়াস অ্যাডভার্স ইভেন্ট হবে কি হবে অ্যাক্সিডেন্ট হয়ে মারা গেছে
No, if the accident is caused because of
The accident is direct.
maybe some drowsiness or blurriness.
আচ্ছা এবারে আমি একটু এক্সাম্পলটা বলি ট্রায়ালে পার্টিসিপেট করেছিল ট্রায়াল মেডিসিনটা খেয়ে গাছতলায় বসেছিল গিয়ে মাথার উপর তাল পড়লো পড়ে মরে গেল এবার যারা বলছেন হবেন না আমি একটা যুক্তি বলি ওটা খেয়ে ওই ওষুধটা খাওয়ার পরেও ডিজিনেস হচ্ছিল সেজন্য গাছতলায় গিয়ে বসে তাহলে মাথার উপর তালটা পড়ে গেল তো লয়ার কিন্তু সেই লাইনে নিয়ে যাবে so all the events whichever is occurring after participation in the clinical trial they are considered as adverse event some are serious adverse event সেগুলো কোনগুলো ডেথ হতে পারে হসপিটালাইজেশন হতে পারে কেউ অলরেডি হসপিটালাইজ ছিল সেখানে দুদিনে ছুটি হতে পারতো 7 দিন হয়ে গেল সো প্রলংগেশন অফ হসপিটালাইজেশন সেটা হতে পারে কারোর ইউটেরাসে ফিটাস ছিল বাচ্চা ছিল সেটা ক্ষতি হলো সেটা হতে পারে কনজেনিটাল অ্যানোমালি হতে পারে so these are considered as serious adverse event and once the causality is detected যে এইটা ড্রাগের সাথে রিলেটেড ছিল কি ছিল না সেইটা ডিটেকশন হলে তখন আমরা ওটাকে এফেক্ট বলবো বাট ইভেন্ট ইজ देयर যা কিছু হবে সেটাই ইভেন্ট মাথায় তাল পড়লেও ইভেন্ট মোচট খেয়ে পড়ে গেলেও ইভেন্ট সো এভরিথিং ইজ ইভেন্ট ঠিক আছে তো কম্পেনসেশন এবং সেখানে বলা হলো যে এই যে লোকটা পড়ে গেল কোম্পানি বলছে না ওটা আমার জন্য হয়নি ঠিক আছে ওটা অন্য কারণে হয়েছে সিবিএসইও বলছে ওটা তোমার জন্য হোক আর না হোক লোকটা যতক্ষণ না সেরে উঠছে ততক্ষণ তার মেডিকেল ম্যানেজমেন্টের খরচ তোমাকে দিতে হবে কারণ তোমার স্পন্সরশিপে ট্রায়ালটা হচ্ছে সুতরাং এটা তোমার দায়িত্ব যদি কখনো প্রমাণিত হয় যে এটা তোমার ড্রাগ থেকে হয়নি তখন তুমি এটা বন্ধ করতে পারবে তারপরে খরচ যা করবে সেই পেশেন্ট পার্টি করবে কিন্তু যতক্ষণ না সেটা প্রুভ হচ্ছে ততক্ষণ পর্যন্ত তোমাকে এটা করে যেতে হবে ঠিক আছে তাহলে মেডিকেল ম্যানেজমেন্ট অফ দ্য সাবজেক্টস সো হোয়াটস নিউ সো দে মেনশন ফর দ্য ফার্স্ট টাইম two ethics committees one for clinical trials so all these are institutional ethics committees one for this is for the clinical trial and for the BAVE studies that have availability bioequivalence study which are utilized for generic drug development and the other group will be biomedical and health research which are clinical research but not clinical trials observational studies hote pare onno kichu hote pare তাহলে দুটো এথিক্স কমিটি থাকবে দুটো এথিক্স কমিটিতে লোকজনকে ট্রেনিং দেওয়া হলো তাদেরকে রেগুলার মিটিং করার কথা বললো এবং বলা হলো যে কোনো যদি অ্যাডভার্স ইভেন্ট হয় তাহলে সেটা রিপোর্ট তৈরি করাও তোমার কাজ দিল্লিতে পাঠাবে তাহলে বেনিফিটটা কার হবে তাহলে এই রুলটাতে এই চেঞ্জটা যে হলো এটা হু উইল বি বেনিফিটেড ট্রায়াল পার্টিসিপেন্টস তাই তো তাদের প্রোটেকশনের জন্য গভর্নমেন্ট এই ব্যবস্থাগুলো করলো তাহলে দিস ইজ ফেভারিং দি পার্টিসিপেন্টস ওকে তো এবার ইন্ডাস্ট্রি বলল আপনি তো শুধু ওদেরকেই দেখেন আমাদের দিকে দেখছেনই না তাই না তাহলে ইন্ডাস্ট্রির জন্য কিছু করতে হবে তো বলে ঠিক আছে তোমাদের জন্য ব্যবস্থা করব কি করব যে ইন্ডিয়াকে নিয়ে প্রবলেম ছিল ইন্ডিয়ার লোকজন লেট লতিফ মানে যখন একটা রেগুলেটরি সাবমিশন করা হতো আইএমডি অ্যাপ্লিকেশন যে আমি ক্লিনিক্যাল ট্রায়াল করতে চাই দেখা যেত সেটার পারমিশন আসতে 3 মাস 6 মাস কতদিন লাগবে কেউ জানে না অনেকটা ইন্ডিয়ান জার্নালে নিজের আর্টিকেল সাবমিট করার মতো কতদিনের রেসপন্স আসবে কেউ জানে না হ্যাঁ বা না সেটাও বলবে না ঠিক আছে সেই অবস্থা ছিল তো এনডিসিটি বলল তোমাকে এখন থেকে আমি বলে দিলাম যদি এটা ইন্ডিয়াতে ডেভেলপ মলিকুল হয় 30 ডেজের মধ্যে তোমাকে আমি পারমিশন দেব বলো যদি 30 ডেজের মধ্যে আপনার ঘুম না ভাঙে বলো তাহলে ধরে নাও যে তুমি পারমিশন পেয়ে গেছো ইউ ক্যান কন্টিনিউ তাহলে দিস ইজ এ টাইম বাউন্ড পলিসি আর যদি ওই ড্রাগটা ইন্ডিয়াতে ট্রায়াল হচ্ছে বাট ইট ওয়াজ ডেভেলপড সামওয়্যার এলস তাহলে তোমাকে 90 ডেজের মধ্যে আমি রেসপন্স দেব কারণ সামওয়্যার এলস মানে সেটা ইউএসএ আবার মোজাম্বিকও হতে পারে সবগুলো কান্ট্রি রেগুলেটরি এনভায়রনমেন্ট একরকম নয় তাহলে সেখানে 90 ডেজ কিন্তু বাকি ইন্ডিয়াতে যদি হয় মেক ইন ইন্ডিয়া মানে 30 ডেজ। কোম্পানি বললো বেশ ভালো, আগে কোনো খবরই পেতাম না, এখন তো 30 দিনের মধ্যে আমি খবর পাবো, আর খবর না পেলে আরো ভালো। ঠিক আছে, তাহলে this is favoring industry. Okay, post trial access in clinical trials. Post trial access মানে I was a trial participant এমন একটা কোন রোগের জন্য যেখানে আমাকে একটা নতুন ইনভেস্টিগেশনাল নিউ ড্রাগ দেওয়া হচ্ছে, ট্রায়াল আর্মে ছিল, and I got benefited. তোমরা এখানে যারা আছো হিন্দি সিনেমা টিনেমা দেখো? দেখো, বরফি দেখেছিলে? বরফি দেখেছিলে? কে কে দেখোনি? অনেকেই দেখেনি, হাত তুলছে দেখেনি। বরফির ডাইরেক্টর নাম জানো? Anurag Basu. Anurag Basu was suffering from a rare type of cancer, and he was under treatment at Tata Memorial Hospital, Mumbai. And that time, the CML, chronic myeloid leukemia, imatinib আসেনি বাজারে, তার আগে স্টেপে যে সমস্ত হাইড্রক্সি ইউরিয়া বা যেগুলো দিয়ে ট্রিটমেন্ট চলতো, ওনার বাঁচার মতন অবস্থা ছিল না, হি ওয়াজ অলমোস্ট কোম্যাটিক। সেই অবস্থায় ওনার ফ্যামিলি মেম্বার্সরা ট্রায়াল পার্টিসিপেশনের জন্য পারমিশন দেয়, and he was started with the trial drug and was benefited magically. He is a cancer survivor এবং তারপরে এতগুলো হিট সিনেমা দিয়েছে। ঠিক আছে, তাহলে এই যে ইনভেস্টিগেশনাল নিউ ড্রাগ যেটাতে বেনিফিট পেলো, বেনিফিট তো পেলো যতদিন ট্রায়ালের মধ্যে ছিল, 2 মাস ট্রায়ালে থাকলো, তারপরে ট্রায়াল শেষ হয়ে যাচ্ছে। এবার সেই ড্রাগটা মার্কেটিং অ্যাপ্রুভাল পাবে কি পাবে না, বা 4 বছর পরে পাবে, তাহলে তার মধ্যে কি হবে? তাহলে কি সেই লোকটা মাঝের 4 বছর কোনো ওষুধ পাবে না, না সেই পুরনো ওষুধগুলোই পাবে? রেগুলেটরস অফ ইন্ডিয়া তারা বলে দিল, you have to provide post trial access to these medicines if it really benefited the subject. তাহলে যদি প্রিন্সিপাল ইনভেস্টিগেটর মনে করেন যে এই ড্রাগটা দিয়ে এই লোকটার বেনিফিট হয়েছিল, দি স্পন্সর মানে যে ফার্মা কোম্পানি বা যারা স্পন্সরশিপ ওই ড্রাগটাকে তৈরি করেছিল, তাদেরকে ওই ওষুধটা দিয়ে যেতে হবে ফ্রি অফ কস্ট টু দ্য পার্টিসিপেন্ট টিল নাও, টিল যতদিন পর্যন্ত ওটা না মার্কেটিং অ্যাপ্রুভাল পাচ্ছে। বোঝা গেল? সো দিস ইজ পোস্ট ট্রায়াল অ্যাক্সেস। তাহলে পোস্ট ট্রায়াল অ্যাক্সেস কাকে বেনিফিট করলো? অবভিয়াসলি সাবজেক্টদেরকে। তাহলে বলটা কি হলো? প্রথমটা ছিল আমরা বললাম এথিক্স কমিটি, সেটাতে বলটা ছিল সাবজেক্টদের দিকে। তারপরে বললো 30 দিনে তোমাকে আমি রেগুলেট করে দেবো সমস্ত কিছু, চলে গেল ইন্ডাস্ট্রির দিকে। এবার 2-1 এরা এগিয়ে গেল যে পোস্ট ট্রায়াল অ্যাক্সেস। ঠিক আছে, পোস্ট ট্রায়াল অ্যাক্সেস কার কাছ থেকে আসবে? ফ্রি ফ্রম স্পন্সর। স্পন্সর বললো আবার হেভি জ্বালাচ্ছেন আপনারা, আমরা কাজ করব কি করে? তারপরে বললো একাডেমিক ক্লিনিক্যাল ট্রায়াল। একাডেমিক ক্লিনিক্যাল ট্রায়াল মানে যেগুলো ইন্ডাস্ট্রি স্পন্সর করে না, অলরেডি অ্যাপ্রুভড ড্রাগ, it is being utilized for new dose, new indication, new route, and done not for regulatory approvals, for scientific purpose only. In this way, many of the drugs, they had new indications, অনেক নতুন নতুন ইন্ডিকেশন, লাইক ডেক্সামেথাসোন অরিজিনালি এসেছিল কর্টিকোস্টেরয়েড হিসেবে, তাকে দেখা যায় কেমোথেরাপি ইনডিউস নশিয়া ভমিটিং এ ইউজ করা হয়। এটা তো বমির ওষুধ নয়, কেন ইউজ করা হয়? দেখা গেছে অনেক একাডেমিক ক্লিনিক্যাল ট্রায়াল ইট সাপোর্টেড কি এটা বমির সঙ্গে দিলে পেশেন্ট বেশি বেনিফিটেড। তাহলে এদেরকে বললো, আগে বলা হতো যে তোমাদের তো ডিসিজিআই এর পারমিশন নিতে হবে, এখন বলা হলো কোনো দরকার নেই, তোমার এথিক্স কমিটি যদি তোমাকে অ্যাপ্রুভাল দেয়, ইউ ক্যান জলি ওয়েল ডু। ঠিক আছে, তাহলে এটা কাকে বেনিফিট করলো? থার্ড পার্টি একটা রয়েছে, একাডেমিক ক্লিনিক্যাল রিসার্চার, তাদেরকে বেনিফিট করলো। My first work in the clinical trial field was with olanzapine. How many of you know the name of olanzapine? Olanzapine কিসের ওষুধ? Antipsychotic. Very nice. So it is an atypical antipsychotic. It just changed the paradigm of, it was a paradigm shift in the industry of psychiatry. Olanzapine for different type of psychiatric disease. In India, we conducted the first study of olanzapine for chemotherapy-induced nausea and vomiting. Why? Because nausea and vomiting, these were some unsolved question all over the world. Drugs like platinum compounds, madam naam bolechilen oxaliplatin. So oxaliplatin is a moderately emetogenic chemotherapy. মানে সাবজেক্টদের মধ্যে যাদেরকে দেওয়া হয় 30 to 89% of the people will develop MSCs after the chemotherapy. And if it is cisplatin, oxaliplatin এর বর্দা, the chance of MSCs goes 90 to 100%. মানে 100 জনকে দিলে 90 জনই বমি করবে। বমির থেকেও বেশি ইরিটেটিং হচ্ছে নশিয়া, যে বমি হলো না কিন্তু বমি বমি ভাবটা পারসিস্ট করছে। তো নরমালি আমরা কি করি, বমি করলে আমাদের অনেক সময় রিলিফ হয়ে যায়। But these cancer patients, chemotherapy patients, they don't get that benefit. So for the patients of chemotherapy from highly emetogenic or the compounds, doxorubicin এর নাম বলেন উনি ব্রেস্ট ক্যান্সারের জন্য ইউজ করা হয়। So doxorubicin, so AC chemotherapy, cyclophosphamide and doxorubicin or FAC compound, 5-fluorouracil add করে, they are also highly emetogenic combination. So breast cancer patients, they suffer extensively from nausea and vomiting. 5 দিন 6 দিন 7 দিন ধরে চলবে। Then in the next cycle they again suffer from nausea and vomiting. So we started it as an add-on drug to 5-HT3 inhibitors and dexamethasone, and it was a magic. How it worked? It was a simple case of drug repurposing. We found that this drug, olanzapine, it blocks a number of receptors in the CNS. So it blocks histaminergic receptor, it blocks serotonergic receptors, it blocks dopaminergic receptors, cholinergic receptors even, and there is potential that this could be beneficial. And I was directly fighting with some pharma manufacturers who were giving a molecule at a cost of 1,500 rupees for one cycle, 3 capsules that time. And we are offering solution of 15 rupees. So this was academic clinical trial. And now olanzapine is in the guidelines of all over the world. So American Society of Clinical Oncology, it is there in their guidelines, ESMO guidelines. So all the international guidelines, now they contain olanzapine as an add-on drug. Okay. So medical management of the subject, there is a clear and explicit description. We already discussed them. Favoring the participants. Approval of new drug, it is again favoring the industry. So disposal of new drug application in 90 days. Okay, fine. So how much? 5 minutes? Huh? Okay, fine. So provision of accelerated approval. কিছু কিছু কেসে যেরকম কোনো একটা এমন কোনো সিচুয়েশন এলো, একটা পাবলিক হেলথ ইমার্জেন্সি লাইক কোভিড, এরকম সিচুয়েশনে কোনো কোম্পানি যদি ম্যানুফ্যাকচার করতে যায়, দেন অ্যাক্সিলারেটেড অ্যাপ্রুভাল, তোমার 30 দিনও ওয়েট করতে হবে না, আরো তাড়াতাড়ি 7 দিনে অ্যাপ্রুভাল হয়ে যেতে পারে। So expedited review if asked by the sponsor, modified or new claims, the clinical data requirement may be relaxed or omitted. Animal toxicity study to be done as per the ICH guidelines. Waiver of local clinical trial in cases of emergency if it is approved elsewhere. So these were some of the things which were favoring the industry. For chronic disease, rare disease drugs and conditions with unmet need like HIV, XDR-TB, extreme drug resistant TB, H1N1, dengue, malaria, which are phase 4 clinical trial may be relaxed. Government ei khamata ei rule kore dibe. So all these things were providing great benefit to the industry. So this is procedure of compensation. Investigator ke within 24 hours of serious adverse event inform korta hai institutional ethics committee ke, licensing authority ke and sponsor ke. Not going in detail, already আমার কাছে ঘন্টা বাজিয়ে দিয়েছে, বাট যেটা ফাইনাল কথা সেটা হচ্ছে যদি একটা সিরিয়াস অ্যাডভার্স ইভেন্ট হয়, একটা লোক যদি মরে যায়, ট্রায়াল চলাকালীন কত দিনের মধ্যে কম্পেনসেশন আসবে? এনি আইডিয়া? কম্পেনসেশন চাইলেই তো কম্পেনসেশন হবে না। এক্স্যাক্টলি। তাহলে এটা ডি এর মতন হতে পারে না, সেরকম নয়। এখানে পরিষ্কার টাইমলাইন ফিক্স করে দেওয়া হলো যে স্পন্সর কতদিনের মধ্যে রেসপন্ড করতে হবে, আর সিডিএসসিও তারা একটা এক্সপার্ট কমিটি বসাবে, তারা কতদিনের মধ্যে রিপোর্ট দেবে। ফাইনালি 120 দিনের মধ্যে কেসটাকে রিজলভ করতে হবে। 120 দিন মানে 4 months. This is one of the fastest possible solution all over the world for the clinical research industry. Okay. So, institutional ethics committee, more autonomy, etc. Amendments has been done in the LDCT Act several times. Updated. In a nutshell, it is a comprehensive rule, time-bound disposals and full digital submission. Submission process, everything was made digital. So this was something good for the industry. Okay. Registration and listing of clinical trials. কোথায় করতে হবে? ctri.nic.in. কবে থেকে আছে? 2007 থেকে। প্রত্যেকটা ট্রায়ালকে প্রসপেক্টিভলি রেজিস্টার করতে হবে। এমন নয় যে আমি ট্রায়াল করিয়ে নিয়ে পরে একটা লিখে দিলাম, কোনো স্কোপ নেই। Once it gets approved from your ethics committee, you have to mandatorily register for the clinical trial at the CTRI registry. Who maintains it? ICMR. ICMR, National Institute of Medical Statistics, তারা এটাকে মেইনটেইন করে। Again, this is free, completely digital process, and viewer can see the ongoing clinical trials in the country so that there is no duplication. Okay. So compensation, আগে আমাদের শিডিউল ওয়াইএ ছিল রুল নাম্বার 122 DAB, এখান থেকে এখন এনডিসিটি অ্যাক্টে সেটা ট্রান্সফার হয়েছে, নিউ ড্রাগস এন্ড ক্লিনিক্যাল ট্রায়াল রুলস। এখানে চ্যাপ্টার 6 ডিলস উইথ দিস থিং। So clinical trial and BAB study, accidental or unintended injuries due to various reasons, death or serious adverse event, তাহলে এখানে compensation দিতে হবে। কে দেবে? Who will give? Sponsor. Medical management, we had already discussed. কে দেবে medical management? Who will give the medical management? Cost of medical management? Sponsor, obviously sponsor. Now coming to the next point, trial sites. So India has good options from the medical colleges, tertiary care hospitals, okay, and we have accredited laboratories which may favor the clinical trial platform. Next হচ্ছে support infrastructure. আজকে যে কোনো trial conduct করতে গেলে we need good internet and good Wi-Fi because data are captured on the electronic data capture system, which is called EDC. EDC platform ke kaaj korate gele internet dorkar. We have a very good internet penetration all over the countries, which is favoring these clinical trials, and we also have extensive road and rail network at present, which is again favorable for the clinical trial industry. Human resource in the clinical trial. So we have clinical pharmacologists and other medical doctors who becomes the PI, support staff from the pharmacy group and also the biologists. So medical colleges of the countries and the pharmacy colleges, there are structured training programs for clinical research, and also some other training institutes jara clinical trial training there to develop skills of the support staff. Okay. Fund flow from the industry. So multinational domestic manufacturers tara fund flow there. There are more than 100 CROs operating in India. And government level, so we have these funders which provide fund for any research, including the clinical trials. Okay. And the last point is the adaptive design. So there are a lot of changes all over the world. So there is concepts like decentralized clinical trials, virtual clinical trials, remote patient monitoring. Patient ka age prottekta monitoring er jonne site aste hoto. এখন দেখা যাচ্ছে তার হাতে একটা ওয়্যারেবল লাগানো রয়েছে, সেখান থেকে আমি তার হার্ট রেটের ইনফরমেশন পেয়ে যাচ্ছি বা টেলিফোনিক কনসালটেশন হচ্ছে। তাহলে এই সব সিচুয়েশন গুলো এখন নিউলি ইভলভিং। সো অল দিস থিংস has improved the data capture and made the data capture faster. Okay? So what is the market share, contribution and projections? Projected future of India. in clinical trial industry. এতক্ষণ পর্যন্ত আমরা কি প্ল্যাটফর্ম দিয়েছি সেটা বললাম। লাস্টে ছোট্ট করে আমরা একটু আমাদের প্রেজেন্ট সিনারিওটা জেনে নিই। 2011 পর্যন্ত লাফিয়ে উঠেছিল, তারপরে হঠাৎ করে ফল করে গেছিল, তারপরে কি দাঁড়ালো? So this is the recent publication, June 25, 2023. Winds of change, global clinical trial revival. India poised for more research coming in its way. So after this COVID pandemic, lot of inflows and new clinical trials are in the pipeline of India. India's contribution to global clinical trial at present is 4%, just 4%. During 2010 to 22, এর মধ্যে কোভিড এর জন্য একটা বড় টাইম ডিসরাপ্টেড ছিল। And this is the projection. So in this projection, it says that approximately 8.2% rate will be the growth rate of clinical trial industry in India till 2030. So this was published in the Grand Prix Research very recently. And in the summary, clinical trials in India have crossed both high and low. Trial-related irregularities are not uncommon. Irregularities are not common, but not uncommon also. Remedial steps has been taken by the Indian regulators to safeguard the participants. India offers a faster approval and timely disposal of the issues now. Infrastructure, competent trial sites, and ethics committees are improving day by day and promoting the trials. Dynamic and a vibrant market is attractive for the global players of clinical research, still at a lower cost than rest of the world. So money is the ultimate honey. So they are giving the best monetary benefit all over the world, has a huge potential to grow at a regular pace and absorb many of you in your future in this clinical research industries. So hope for a brighter tomorrow. So this is the place where I work. This is the ICMR National Institute of Cholera and Endemic Diseases. Thank you. You can contact me. Keeping you away from your lunch for such a long time.
Thank you so much, sir. No, actually, we started a little bit late, or we got late a little bit at the beginning. That's why this thing happened. It's not because of you, sir. So I don't want to mention that. So it's not like that. It's because of you. I would like to request if any participant having any questions regarding the session, please raise your hand. So I'll pass on the mic to you. Any question regarding the clinical trial and the information sir has provided? Sir, I have a question to be specific. Recently, maybe in the LinkedIn, I have seen somewhere that in the LinkedIn, I could not say the exact people who has posted that the preclinical trial, that the trial with the animals has been banned or is going to be banned in coming times, or has been banned by FDA, if I'm not being so wrong. So, like, if that is being banned, then how? What do you think about it, or how things will be?
First of all, preclinical studies are preclinical studies. These are not trials.
Preclinical
So
studies.
this is a misconception.
Right.
Trials are only in the human.
Humans, right?
So preclinical studies are frequently under scanner because of less predictivity.
Right.
Because the drug development, you cannot do things which are not giving you benefit. Okay. Unless it predicts reliably, automatically the importance will go down. So in many cases, they have reduced the importance of the preclinical studies. They have not made it obsolete. It is not possible at the present scenario to make it obsolete. But newer technologies are emerging. So lot of information are now coming from phase 0 clinical trial. Microdosing studies. Okay. And there are a lot of things which are coming in the form of software and AI. So we can get some simulation things done. So a lot of things are coming which are changing the scenario. The whole thing is very dynamic.
Right.
So in many cases, these preclinical studies are absolutely not producing any benefit. Okay. So why to kill the animal?
Right.
So that is the reason. So some of the cases in India, like cosmetic testing on the eyes of the rabbits, this has been probably came with some scrutiny, and probably it will be banned or something.
Any more questions from the audience, from the participants?
If you want to do some research or some do business in clinical trial, as a pharmacist, how can you do? How can you
Basically, as a pharmacist, you can get absorbed in the team. So clinical trials, the basic need for becoming a PI, only a medical doctor in India can become a PI. In some other countries, they may have something different. But in India, because the PI definition is the person who can take the medical decisions. So when there is some health jeopardy during the trial, so only the medical people, if he is trained, he can take the medical decisions. But the trial is not only by a PI. So it is a set of team of big people. So the pharmacist can be a big part of the team because they have knowledge of the drugs. Because most of the other biology field people, they have the area knowledge of the drug. They even don't know the name of the drugs. But you have gone through.
As a liaison also can work.
As a liaison, you can work. As a team member, as a clinical research associate, if we get someone from the pharmacy field, we may get benefit. For pharmacovigilance part, for the safety part, safety recording part, clinical data management part, so all these parts. So there are several components in a clinical trial. So I am not saying that every pharmacist will be able to do like that. If the pharmacists get adequately trained, they could be in a better position to absorb those jobs.
Thank you, sir. Anybody else? So now we would like to go for the felicitation of our speaker. I would like to request Professor Kamala Roy sir to felicitate our speaker. Volunteers are requested to help. Thank you, so much, sir. I request Professor Roy sir to stay back a little bit and would like to request ma'am to come here for once. Sorry, ma'am.
I think delegates really awaiting because their stomachs are full of not with full of information. So they are waiting for the lunch.
So it is our part that we would like to felicitate ma'am as well. We haven't yet given the certificate of the participation and appreciation from our department. Thank you again, ma'am. Joining with us. Thank you, ma'am. So the wait time is over, so it's the lunch time. Now I'm announcing it's the lunch time, so we'll be having a half an hour lunch time. So the participant students should go to the room number 516 and the please make a row, and the guest faculty, guest teachers will be going to 714 to have the lunch. And we have only half an hour to complete your lunch within half an hour and come by within half an hour in this auditorium. Room number 516. The students and participants will go to room number 516. It is the fourth floor. Fourth floor, room number 516. Please come with me.